is basically funded by the Ministry of Education of Taiwan, and the purpose of this conference is promote academic communication and exchange ideas among the scholars, and also definitely is strongly supported by the Office of International Affairs in NTU. So now I would like to welcome our honorable guest, Associate Vice President for the International Affairs of NTU, to give us opening speech. Welcome, Professor Lee.
Yeah, thank you, Professor Ding. Good morning, distinguished guests and colleagues, ladies and gentlemen. I'm Junhao Lee from the OIA in NTU. So on behalf of the NTU and the Office of International Affairs, it's my pleasure to welcome all of you to 2021 Taiwan-Thailand Air Quality Forum. So we are delighted we are able to welcome over 10 distinguished guests from NTU and Thailand as our speakers. Thank you for joining us today. So NTU has been working closely with our Thailand partners, collaborating in various academic programs and research fields with the development of technology in industry and economy. Air pollution has been an important issue in recent decades. The impact of the air quality, human health, and the climate change cannot be ignored. So in order to clarify the impact of the aerosol and provide effective some strategy to manipulate this aerosol in Asia. So regional cooperation and academic exchange will improve local and regional air quality. So we thank you, Professor Ding, Yu Jie Ding from Graduate Institute of Environmental Engineering of NTU, hold this forum to exchange experience between Taiwan and Thailand, as well as invite local experts and scholars in this field to share knowledge about the current research directions. So exploring the potential collaboration and strengthen relationship with the research community in Southeast Asian countries, and serve as a base for future concrete collaborative research. And actually, when I see the agenda, I see lots of interesting topics, such as the characterization from the optical property, chemical property of the air and as aerosol, and as well as local or global control of the PM 2.5 aerosol. And also I saw some simulation, and especially about the relation about the COVID-19. So I think that's very quite interesting topic, and we believe that this forum will propose a preliminary direction as a beginning of the bilateral connection. So in the past 2 years, we are confronted with unforeseen challenge posed by COVID-19 pandemic. It's your commitment to research and innovation, your faith in collaboration and demonstration of resilience that give us a chance to join today's forum. Thank you again for coming, and we look forward to growing friendship and partnership. Thank you very much.
Thank you, Professor Lee's speech. It's almost like introduce all the topics. So for today's air quality conference, I think the main scholars from NTU are Professor Xu, Professor Xiao, and me, and we are working in the Graduate Institute of Environmental Engineering. So now I would like to specially invite the director of the Graduate Institute of Environmental Engineering. Let's welcome Professor Che.
Yes, thank you, Professor Ding. Good morning, everyone. Vice President Professor Lee, our distinguished speakers from 6 universities in Thailand, and my colleagues in the Graduate Institute of Environmental Engineering. Ladies and gentlemen, welcome to the forum in Concord for the pressing issues of air pollution. It's my privilege to give this opening address in today's online meeting on behalf of our institute. Our institute was established in 1977. Currently, we have 12 full-time faculty and 19 adjunct professors. And we have 59 PhD students and 122 master program students. Our research focuses on various fields of environmental engineering. Today, I'm pleased to see we started a collaboration with you in air quality research. It's my honor to introduce my three colleagues who will contribute to today's meeting. Professor Xi, Professor Xiao, and today's organizer, Professor Ding. They all dedicated themselves to air pollution-related research and have outstanding performances. I believe you have all heard of them. Air quality has always been the first priority for better hygiene, airborne disease prevention, and living amenity, except for traditionally regulated air pollutants. The scale is down to PM 2.5 and smaller aerosols. The control is expanded to limit hazardous substances such as PAH and even suppress virus dissemination such as COVID-19. I'm so glad to gather so many professors and experts in this field together here. Let's leverage our connections and share our research results through this forum. I wish today's event a great success and all participants good health and well-being. Thank you. Thank you for joining us.
Thank you, Professor Che. So I think it's a bit earlier. I think we can start from now. So the conference officially starts now. And before we start the session one, I would like to give the time to the chairman of the session one. But before that, we need to take a photo for all of us. So yeah, and so when the photographer ready, please let us know.
3, 2, 1. Okay.
Okay, thank you.
Thank
So
you.
now let's start the session one, and I will give the time to the chairman of session one, Professor Sirama Yameki Kuo. Please, Professor Sirama. Oops.
Thanks, Danny. Hello.
Yeah, we can hear you. I can hear you.
Okay, right. Thanks. Welcome, everyone. Thank you for joining us for Taiwan and Thailand Air Quality Conference. And this is the first session of the forum. My name is Rima, as your session chair, and I'm a director of the Thailand Network Center on Air Quality Management, or TAQM, Chulalongkorn University. The first session, we are presenting 3 topics, starting with 2 ladies from Chiang Mai University, Professor Somporn and Miss Charita, and Professor Danny from National Taiwan University. Before we get started, kindly mute your mic. Okay, I think I am back. Before we get started, please mute your microphone when you are not speaking. And if you have any question during the presentation, please type them into the Q&A box or chat box in your control panel. And I will read the question after the talk, or you could ask the speaker directly, as we will have 5 minutes for questions toward the end of each speaker. And speakers, you have 20 minutes each. I will interrupt you a few minutes before the talk finishes, and I will stop you if the time is up. Okay, let's get started on time. I'm proudly present and our speaker. She's kind of the key person who's done a lot of work in the hate situation in northern Thailand. Our first speaker, Professor Somporn from Chiang Mai University. She's going to talk on flesh and agent aerosol and side fractionated PM bound PAH in urban and rural atmosphere in northern Thailand. Professor Somporn, are you ready?
Yes, I'm ready.
Yes, the floor is yours, please.
Thank you very much. Good morning, everyone. Thank you for your kind introduction, Professor Surima. I would like to start by sharing my PowerPoint slide. Can you now see my screen? Okay. Maybe I start with introduce myself a little bit. My name is Somporn Jantara from the chemistry department, and I am now the head of the Environmental Science Research Center, Faculty of Science, Chiang Mai University, Thailand. It's my pleasure today to be a speaker of this conference. And as Professor Surima already introduced my title, so I will skip this one. This work has been already published in the papers, the first one in chemosphere and the second one in the environmental pollution. They are already online. If you are interested, you can download it later. And the objectives of this work are to monitor ambient PM 2.5 and size fractionated PM or SPM from traffic and biomass burning source. The second one is to analyze water-soluble ions of PM 2.5 in relation to their emission source, and to analyze the SPM-bound PAH to assess respiratory health risk. Our sampling size for both PM 2.5 and SPMs are in northern Thailand. As you can see in the map, here at the star, you can see our sampling location. We have categorized our sampling size into urban sites and rural sites. For urban sites, we have Chiang Mai City and Lampang City. For the rural sites, we have Chiang Dao District, which is also in Chiang Mai province. And another one is Mae Sariang. Mae Sariang is in Mae Hong Son province. This site is located near Myanmar border. And for the SPM sampling, we have chosen only 2 sampling sites in Chiang Mai province due to the limitation of our equipment. For the PM 2.5 sampling equipment, we use the low volume air sampler PQ200 and mini volume air sampler, the air metric, for collecting our 24-hour PM 2.5 samples on daily basis to represent the different off seasons in the year 2019. For the method of analysis of the water-soluble ions, we use the deionized water and extract our sample in ultrasonicator. And we analyze them by using ion chromatograph for both cations and anions. In case of the sampling size for the SPM samples, the urban area study site, we chose the Northern Meteorological Center office, which is located near the Chiang Mai International Airport and considered as the busy area of Chiang Mai City. For the rural area, to collect the SPM samples in Chiang Dao district, we selected the sampling site, which is surrounded by agricultural field and not so far from the forest area. So it has quite intensive open burning in this area. For the SPM collection, we use the 8-stage cascade impactors, as you can see in this slide from Tisch, USA. And we can collect 8-stage sample from the coarse PM 9 to 10 micron up to the finest PM from 0.4 up to about 0.6 micron. And we use the quartz fiber filter to collect the samples. And we divided our sampling size into the smoke haze period from March to April and from non-smoke haze period during May to June and November in 2019. So we collect each sample for 24 hours to have enough PM mass. For the extraction and analysis of PAH, we use 25 milliliter of dichloromethane mixed with hexane and extract them in the ultrasonicator for 45 minutes under the low temperature, less than 10 degrees Celsius. We evaporate them and add the internal standards and analyze by GCMS. I would like to talk first about the PM2.5 bound ions for source identification. This graph shows the PM2.5 concentration obtained from 4 study sites. So we have CM as Chiang Mai urban area, Chiang Dao or CD rural area, Lampang urban area, and Mesariang rural area. So you can see the pattern of PM2.5 concentrations during the smoke haze season, which are quite the same for all sampling sites. And this bar graph is the fire hotspot count in northern Thailand at the same time. So you can see that the pattern of all sampling sites are not so different. However, when we calculate the average values of PM2.5 for each sampling site, we can see that the average value at the Chiang Dao rural site was the highest value, above 100 microgram per cubic meter. But it's also close to the value obtained from Lampang city. And Chiang Mai got the lowest concentration at about 70 microgram per cubic meters. For ion concentrations, this graph shows concentration of ions on daily basis according to our sampling. We can see a good correlation between ion concentrations and PM2.5 for each sampling site. And when we adjust the value to 100%, we can see that when we compare the seasons, hot dry season normally means the smoke haze season in March and April, and wet season and cool dry season is in November and December. From Chiang Mai, Lamphun, Chiang Dao, and Mesariang sites, you can see that during the hot dry season, we have almost the same pattern of the ion concentrations or ratio. So we have the gray color here is sulfate and nitrate, and the green one is ammonium. We have potassium ion in this season higher than another seasons, except in cool dry season, because open burning also occur in the cool dry season. But most of the major ions found here is the secondary inorganic aerosols, or SIA, nitrate, sulfate, and ammonium. When we compare our results with the previous studies from our group, at that time we performed the open burning in the open combustion chamber, and we found that the potassium ion and chloride ion were very high, and they emitted mostly from the agricultural residue burnings, for example, from maize residue or rice straw burnings. And when we review the literature, we found the paper from Lee et al. That mentioned about potassium chloride as the young or fresh aerosols or primary pollutant, and potassium nitrate and potassium sulfate as the aged aerosols or secondary pollutants. So in this study, we concluded that potassium chloride is a tracer for fresh aerosols, and potassium nitrate is a tracer for aged aerosols from biomass burning. And when we perform the PCA to see the source, comparing between hot dry season in urban and rural study sites with the other seasons, we found that in urban area and some of the rural area in Mesarian, we found the mix of SIA and from the biomass burning. And for Chiang Dao study site, we found the biomass burning similar to previous study site at Doi Ang Khang. We found both potassium chloride and potassium nitrate. In urban area, in hot dry season and other seasons, so we can conclude that in urban area with or without biomass burning influence, we still find the SIA, for example, ammonium ion, sulfate, and nitrate. And let's go to the conclusion for the PM 2.5 bound ions. We found that the area with intensive open burning, for example, in Chiang Dao area, had the potassium chloride as a main tracer of fresh aerosols emitted from biomass burning. And the secondary PM 2.5 is dominated during the haze episode due to prolonged accumulation. Potassium nitrate is a tracer for aged aerosols from biomass burning, and the potassium chloride turned to potassium nitrate during the aging process. So the source of PM 2.5 during non-smoke haze season depend on the local activities. For example, the secondary ions or ammonium sulfate, which is found in this study, is in the urban area. And biomass burning tracer like potassium chloride and potassium nitrate were found in the rural atmosphere of our study. And now we are moving to the SPM bound PAH for health impact assessment. In this study, we found that most of the PM was less than 2.1 micron. So about 60% of the PM mass was found in the smaller size in urban station. And in rural station, almost 70% of them were detected. And when we analyze for PAH composition in smoke haze period, comparing with non-smoke haze period, So in this graph, you see urban study site in the gray color and rural sampling site in the violet color. So we found very high composition of PAH, the total 16 PAH composition in the PM less than 2.5 micron, more than 80% of them. And during the non-smoke haze period, we also found a very high concentration of PAH in the fine particles. However, in the urban area, we found less percentage of PAH composition in our samples. This is maybe due to the changing of the source, because during non-smoke haze period, there are less biomass burning, but traffic emission get greater in the urban area. So it can be seen clearly in this composition. And when we compare between urban and rural area in both periods, and we divided the PAH into the carcinogenic one and non-carcinogenic one, we found the higher ratio of carcinogenic PAH, which is red color here, higher in the PM less than 3.3 micron in both urban and rural area in both periods. And during non-smoke haze period, we found interesting results here. So the coarse PM, or the PM above 3 micron of the urban area. So from here, we have urban area in this graph. So we have higher ratio of carcinogenic PAH than in rural area. As I mentioned, the traffic source might be related with this finding. And after we got the PAH concentration in each particle size, then we calculate the toxicity equivalent concentration. So we use 3 equations from 3 references, as mentioned here in the graph. And we found the same trend of toxicity. So the highest toxicity were found in the smallest particles, from the 0.4 to 0.6 micron. And from that toxicity equivalent, we can calculate the ICR, or inhalation cancer risk. And this is the result from the smoke haze period. When we compare urban atmosphere sample and rural samples, we can see that there is more risk from our rural area comparing to the urban area, which is the medium risk. This is the samples during the smoke haze period. And when we perform the calculation for the non-smoke haze period, we found the opposite results. So in this graph, you can see the risk of the urban area, or the gray color here, showing higher risk than what we found in the rural area. So this can be concluded that the finest particles, or the 0.4 up to 0.6 micron, contain higher mass concentration, so around 30% of the total PM, and it contains about 50% of total PAH. And during the smoke haze period, the average concentration of the SPM and PAH in the rural area were higher than the urban area due to the intensive open burning. But during the non-smoke haze period, the PAH concentration in the rural area was lower than the urban area, as we know that non-smoke period, we have less open burning. And of course, because of more traffic emission in urban area, so we can see more risk in the urban during non-smoke period. And I come to my last slide. I would like to thank our funding agency, the Thailand Science Research and Innovation, and the PCD for the PM 2.5 data provided, and our research facilities from the Faculty of Science, Chiang Mai University, and my research group, ECIL. So thank you for your kind attention.
All right, thanks you, Professor Somporn. That was an interesting presentation and is very significant finding from your research group. I was looking for the Q&A. Or from the floor, is there any question to Professor Somporn, please?
It's maybe too early to ask.
Well, if not, I don't have the question, but just kind of, as I remember in 2019, you correct the sample in 2019, isn't it?
Yes.
I think that there was a forest fire in Chiang Dao, and it's kind of disaster, right? Did
Yes.
your sampling site is close to that area?
It's not
share
that
anything?
close, but we still can capture some of the plume. Yes.
Oh, I see. So the result that you just mentioned about the intense result from the biomass burning is the effect from the forest fire.
Yes, mostly the open burning in northern Thailand is occur in the forest area rather than in the agricultural area.
Oh, I see. Okay. All right. So any question from the floor?
Yep. Here.
Yes, Danny, please.
So thanks for your presentation, Professor Sapon. Just one question for the sampling pH. I think you use the low volume sampler, which is like 28.3 lpm. Is there any problem to detect the pH? I mean, how many species of pH were determined?
16 compounds were determined. It's not a problem of non-detected PAH because we collect them 48 hours for one sample.
48 hours.
Yes.
Thank you. Yeah.
Yes, please, TC.
So, good morning. Suppose I think we met before in Thailand and also during the 7th
Yeah.
International Cooperation Project. So, my question is more like it's not a question. Just I wonder, do you have data for diurnal pattern of this pH? Do you see the because there is some potential photochemical agent for this pH, especially say like um, one of the tracer, I forgot the potassium nitrate something, could be a tracer for the aged aerosols. I just curious, well, like a sunshine or solar radiation cause any issues with those signal, or do you observe any behavior like diurnal or that kind of tracer?
You mean for the pH analysis or the ion composition?
I mean, it's more like both. First, no, pH could be photoreactive.
I
So,
see.
first, do you have a data for night and day, and do you observe the different pattern like a spectrum or different species more significant in the daytime and the others at nighttime? Why? Like this first. And second, because you say there is a tracer, but that is due to aging, but the aging means they can encounter some like again photochemical aging or oxidation process. And could that be an issue for this tracer?
Yes. For the day and night sampling, we have done it before in maybe 2015 to analyze for the PAH patterns, but we did not publish this paper yet, so I cannot remember there were any differences between day and night or not. But my colleague today, she is with us. She is now drafting the paper. Natiporn, maybe you can remember the difference between day and night pH pattern during 2015 or not? If yes, maybe you can provide some information for Professor TC.
Okay. Between day and night is not actually different during smoking season in 2015, but we also correct two signs of particle PM1 and PM2.5. Between these two sites, we found some difference of pH composition, especially the lower molecular weight. Yet it's actually contain more in the PM2.5 than PM1 for low molecular weight pH. Yes.
And yes, and for the second question about the AH aerosols, yes, we consider them by the changing of the phase. For example, if we found high concentration of sulfate in our samples and we draw the correlation between the ratio of the ions and PM2.5 and plot them with the PM2.5 concentrations. If we found a positive correlation among them, then we concluded that it might form in the atmosphere and it might be the H aerosols rather than the fresh one, because we compare our results previously that we perform it using the open burning chamber, and we found high concentration of potassium and chloride. So that's why we concluded that potassium and chloride might form during the burning. So it's not react later, but the ammonium and sulfate might be react later in the atmosphere. So that's why we concluded like that. I hope I answer your questions. But if you have any comments, you can comment on that.
No, I think that the other two ask more questions.
Uh-huh. Right. Okay, thank you, TC.
No problem. Thanks. Thanks for your great presentation.
Mm-hmm.
Any comment or question from the floor? If not, all right. Thanks very much, Professor Somporn. We will move to the next speaker, Miss Charita. She is from Chiang Mai University, and her topic is improving air quality for sustainability of human, animal, environmental health through a One Health framework. Miss Charita. Okay, the floor is yours, please.
Thank you, Chairman. Good morning, everyone. Actually, I already record my presentation, so I will open my record. Good morning, Chairman, presenters, and all participants. My name is Chalita Jiranti. I'm from Faculty of Veterinary Medicine, Chiang Mai University. My topic today is improving air quality for sustainability of human, animal, environmental health through a One Health framework. I think I have most different background from other presenters today, and I'm quite new to this field of study because my background is veterinarian. So let me introduce myself first. My education background. I have a Doctor of Veterinary Medicine degree from Chiang Mai University, Thailand since 2013. And in 2018, I got Master of Public Health degree from Chiang Mai University and University of Minnesota. My current position is veterinarian and researcher. I work at the Veterinary Public Health and Food Safety Center for Asia Pacific, or VPHPAC, Faculty of Veterinary Medicine, Chiang Mai University, Chiang Mai, Thailand. The Veterinary Public Health and Food Safety Center for Asia Pacific, or VPHPAC, is under the Faculty of Veterinary Medicine, Chiang Mai University. The center's niches are focused on three main areas. The first one is education. We take care of the students in the international program of Master of Science in Veterinary Public Health. Second one is research. We conduct research with collaboration of students, lecturers, and academic partners in the area of food safety, zoonosis, which are diseases that can be transmitted between humans and animals, and epidemiology. And the last one is academic services. We organize trainings and workshops for capacity building in veterinary public health. Our target participants are government and private sectors related to animal health, faculty staff, graduated students, and other stakeholders such as farmers, slaughterhouse owners, food processing staff, and so on. As already mentioned, we manage the Master of Science in Veterinary Public Health International Program, which the former name degree is Master of Veterinary Public Health. In the past, is a joint degree program with Free University Berlin, Germany. But now the collaboration of the MOU has ended, and we changed the name of the program to Master of Science in Veterinary Public Health, and is a standalone program which managed by our center. Since 2003 until now, we have total of 84 alumni and 5 current students from 15 countries in Asia.
Hello,
As
everyone.
listed here. Our research interests in the center, not only researchers, we also have lecturers who work under the center and the master degree students who conduct research as requirement for graduation. The research are focused on infectious zoonotic disease, which are diseases that can be transmitted from farm animals, pets, wildlife to humans. And we also study on microbiological quality of food and foodborne pathogens, specifically focus on bacterial pathogens. And we conduct research on the antimicrobial resistance and drug residues. As you may know that antibiotics have been widely used in food industry in farm animals for disease treatment and used as growth promoter. So the antimicrobial resistant bacteria can contaminate food and have transmitted by consumption products from these animals. And our research interests are also focused on risk analysis in food, contamination, and disease in animals. As I already mentioned about my background, that I didn't have direct experience related to the environmental science, but I have conducted few studies that may relate to the environmental study, such as the seasonal of foodborne diseases and associated environmental risk factors in Chiang Mai and Mae Hong Son provinces in Thailand from 2006 to 2015. The main objective of this study was to assess the seasonal patterns of acute diarrhea and food poisoning and associated climate factors in Chiang Mai and Mae Hong Son provinces. In this study, we collect data on monthly incidence rates of acute diarrhea and food poisoning and meteorological data such as temperature and relative humidity and try to find the association of the climate factors of interest and the disease patterns. Next is the study related to aerosol air quality. This study I work with my colleague, Dr. Colin Chen. The study was published in Oxidation Communication Journal last year. The title is Study on Ozone Oxidation and Aerosol Characteristics of COVID-19. In this study, we discussed about physical and chemical properties of coronavirus and the way that the virus spread in the environment and its aerosol characteristics. Moreover, we also discussed about disinfection mechanism of COVID-19 virus and the oxidation mechanism of disinfection in order to provide understanding of effective way to control the disease. Next is the presentation that was presented in the INCAM conference this year. The title is COVID-19 Chemistry and Diffusion, a conceptual study from the meaning of public health and environmental protection. This presentation will discuss the prevention measures of COVID-19 in the perspective of public health and environmental protection, including social distancing and personal protection measures such as wearing masks, vaccination, and disinfection. This is the highlight of my talk today. I would like to introduce you about One Health framework or One Health concept. One Health is the way that we can work across disciplines. It's a multidisciplinary work to solve the complex problems that cannot be solved by only one profession. So we need many perspectives and many disciplines to work together. As you can see in this diagram, that human health, animal health, and environment are linked together, and One Health is the concept that links all of these three together. One Health is a collaborative, multi-sectoral, and transdisciplinary approach, working at the local, regional, national, and global levels, with the goal of achieving optimal health outcomes, recognizing the interconnection between people, animals, plants, and their shared environment. This is the area that we can work together. As I have background in veterinary and public health, and all of you here may have background in environmental. So this is the way that we can work together. Item lists here are just some examples of issues that we can work together under the One Health concept. And the possible area or scope of research that I list here are the possible study that we can develop together. The first one is air quality or climate change or climate factor study and zoonotic disease. For example, dengue fever. As you know that global warming has been emerged for more decades and has been taken into account due to increase in human and animal health, increase in incidence of disease. So dengue fever is a vector-borne disease that transmit by mosquito. So due to global warming, the pattern of the disease has been changed. And other diseases of interest such as respiratory disease, vector-borne disease, and another scope of study that I list here is the air quality study and the association of food safety or food quality. This is another example of the disease in animals that can be transmitted to humans. Avian influenza. Avian influenza is the disease in poultry, such as chicken and ducks. The disease or the avian influenza virus can be transmitted to human, and human infections are rare but possible. Human can be infected with the virus via direct contact of the animal or contact with contaminated surface and via airborne transmission. That's all of my talk today. Thank you for your kind attention. If you need more information, you can contact me via this email.
Right, thanks, Dr. Charita. This was impressive talk. And well, for my personal interest, well, before ask the audience, is my personal interest. Is there any chance of COVID-19 to transmit between human and cat? Because I have a domestic cat around my house, quite a lot of cats. Is there any possibility?
Possibility of, again, please. Your question is?
Is there a possibility of transmitting COVID from cat to animal or animal?
Yes,
from cat
please.
to human or human to cat?
There are some studies suggest that our pets can be infected from humans rather than human infected from pets. So
Well,
it's vice versa. So our pet can infect COVID from us rather than transmit the virus to us. Yes.
Okay. All right. And one more, please. You mentioned about the study of COVID-19 and ozone oxidation in
Yes.
some slides. Yes. And do you find then any relationship of the COVID infectious of Thai people? I mean the lower infectious of Thai people because of the level of ozone in Thailand is exceeding the standard. Is that any help? Maybe it's kind of the joke of environmentalist.
Yeah, we did not discuss in that area. We did not focus in Thai people only. We discussed about the concept that how can the virus transmit in the air to humans, something like that. Yeah. And I think it's interesting because Thailand also has like worse air quality. So it's interesting study to study that weather is a factor that can associate with the number of cases, something like that.
Okay, so any comment or question from the floor, please?
Can I have a question?
Yes.
Okay. Dr. Janoti, it's a very good research and your presentation. I think it's very good for us because we are all here. Many of the are majorly in the air quality study, but
Yes.
you give a new vision from the one health, from environmental health and animal health and human health. But I think it's maybe you are interested, or maybe our here the member here may be interested to find some of the model. I mean the past model, or to determine the possibilities of the infectious rate, infectious model by the animal, by the animal through the aerosol. I think it's a good topic. Maybe your organization or your institute have the capability to do such kind of research. Maybe you could think about some more research topic together with the professors here. Yeah, that's my comment.
Thank you, Dr. Shen. In
Thanks.
our center, we have also discussed about the effect of PM 2.5 in animal, but finally we did not do the research of that because we think that the animal, their lifespan is so short, so we might not see the effect of PM 2.5 when compared with human. For example, the chicken meat that we eat every day, it takes only 40 days for raising it, and about the cow, it takes just few years to raise it. So it's too short to see the effect of PM 2.5, something like that. Yes.
Oh, I saw.
Okay, thank you.
Dr. Win, please.
Thank you. Thank you very much for your presentation. Very interesting framework for One Health. I have 2 points to, not so much a question, but a point to discuss. So one is my previous work, we did a model of nitrogen dioxide impact to dairy cows. And since we can only do so much taking literature review numbers of like the threshold concentration of nitrogen dioxide that would have the impact to premature mortality in cows, and we do calculations based on that, but we don't know really much in details about how it really impacts, and we just take the review from study in Netherlands. So it would be very interesting if we can maybe pursue deeper in details in collaboration with
Yes.
your research.
Yeah, welcome. Because in our center we have the expert in this, the Catton, and he expert in epidemiological study and modeling. Yeah,
So that's
it's
very cool.
interesting. Yeah.
Another point that I would like to share as an idea is that I used to work in the Department of Highways, and there were impacts that were not really studied in detail, which is the impact of pollution to wildlife. And there are no data, there are no like concentration level standards or like in literature to reference from. So it's really hard to tell like what would be the impact to these wildlife and ecosystem. So I think it would be an area to work on. It has a lot of room to work on. So
Yes.
maybe
Yes,
if you have any comments on that.
Yeah, I agree with that point. Yeah.
It's very hard to extrapolate from since I think you work on like domesticated animals, how difficult to extrapolate from that to wildlife, wild species?
Mm, uh, no, it cannot be concluded like that because each species has its own characteristics, and in the faculty we also have the wildlife department that research on their own perspective, and we also have elephant center because the logo of our university is elephant, right? And we also have the excellence center in elephant, which the research is the top of the world. So we research a lot in elephants. Yeah, but for my own center, we focus on food animals, livestock such as pigs, chickens, and cattle like cow. Yes. So if you interest, I can introduce you to someone that might have common interest about
Right.
wildlife in the faculty. Yes.
Okay. Thank you very much.
Anyone else? All right, thanks, Dr. Chalita. I think as we try to tackle the effect of the COVID-19 pandemic, including the air pollution in this floor, I think we must not forget that the nature and the climate crisis continue to threaten our future. And yes, I do agree that the topic of yours, the One Health approach, and we should support and try to build up the joint research and study more in the near future. Thanks a lot, Dr. Charita.
Thank you.
Okay, for the last speaker of this session, Professor Danny from National Taiwan University. His talk is about characterizing the optical properties of ground carbon in an urban area of northern Taiwan. Please, Danny.
Can you hear me now?
Yes.
Sorry. Okay, yeah. Well, it's me again. So my name is Vijay Ting. So today I would like to show you some preliminary results of my research on the optical properties of brown carbon in the urban area of northern Taiwan, which is in Taipei City. So this is the outline of my presentation. So I will briefly summarize the literature review and why we are carrying out these topics and what the purpose of the research is. And then I will describe the experimental method briefly and show you some preliminary results because there are still a lot of chemical analysis and data analysis is still ongoing. So yeah, and then the follow-up work, of course. And before I start this presentation, I would still like to briefly introduce myself. So I got my PhD degree from the University of Manchester in the UK and started my academic career last year in NTU. So the main research interests for me are the atmospheric chemistry and investigating the physical, chemical, and optical properties of atmospheric pollutants. Of course, mainly focus on the carbonaceous aerosol, and then identify the chromophores of the carbon, especially organic carbon, and then the sources of the pollution and establishing the emission inventory. So currently, I'm working on the properties of organic carbon and black carbon in PM 2.5, and in the near future will be in PM1, and also provide an insight into the impact of aerosol on human health and air quality and climate, which can underpin the mitigation strategy of air pollution. So on the right side, let me close the point. So on the right side, these are the instruments used for my previous research. So they are the AMS to measure non-refractory PM1 and the SP2 to measure the black carbon properties in PM1. Of course, you can use the different inlet for the size selective. And a thermometer, which is mainly measure the absorption coefficient of atmospheric aerosol at different wavelengths. And currently, we characterize the atmospheric aerosol on the basis of filter measurement and apply the HPLC art and high-resolution mass spectrometry to explore the absorbability of water-soluble organic carbon and methanol soluble organic carbon in the wavelength range of UVB light. And also, we are trying to identify the species of the light-absorbing conifers, of course, the brown carbon, and also the sources of it, combining the source apportionment model. So carbonaceous aerosol mainly comprises of organic carbon and black carbon, which are main components of PM2.5, and they can contribute about 20 to 70% of PM2.5, depending on the sources and the regions. And of course, black carbon is mainly emitted from like incomplete combustion, and organic carbon could be primary or like formed by the photochemical reaction or like oxidative reaction of precursors. And from these figures, we can see that the the carbonaceous matter can be classified by different measuring method, which is thermochemical and optical. From like non-refractory organic carbon to elemental carbon, or like colorless organic carbon to black carbon, increased with the like refractiveness and light absorption. So as you can see on this picture, it is the extract of different samples, and you can clearly see that there are different color of the extract by the water-soluble water, which means they have like different light absorbability of the component in the extract. So I think it's well known that the black carbon is powerful climate warming agent by absorbing heat in the atmosphere, which is like second largest anthropogenic pollutant contributing to climate warming, only second to the carbon dioxide. Of course, now carbon is the big issue in the world. So I think it's not just in the gases phase, it's also on the aerosol phase. So in the past, in the previous study on the climate model or climate change, organic matter is generally assumed to be the material completely contribute to climate cooling. However, there have been like several studies focusing on light absorbing organic carbon, which is denoted as brown carbon, because the mass concentration of brown carbon in the atmosphere is much higher than the black carbon, and also is more sensitive and highly absorptive to UVB light, which has non-negligible impact on environment and climate. So this picture demonstrates like simply demonstrate the source of brown carbon and its impact on the environment. So the sources of brown carbon could be like primary, emitted directly from sources, and secondary, which is formed by the photochemical reaction of precursors such as like VOC, PAH, nitroaromatic, phenols, pyrrole-like substance, and biopolymers. So due to its chemical and optical properties and also its reactivity, it can have strong impact on human health, air quality, and climate. So why we are doing this research, because the brown carbon is ubiquitous and also is size dependent, and also it can contribute about like 20 to 50% of the total aerosol absorption of radiation in the like shorter wavelength, which is in the range of UVBs. And also, the previous study showing that contribution of brown carbon to radiation absorption vary greatly, which means like in different regions, which means like in Taiwan, in Thailand, and in the UK, and the US, we have it will show different patterns of the contribution of brown carbon to climate. So apart from that, the brown carbon also plays an important role in photochemical reaction. For example, it can affect the generation of oxygen, so ozone and the hydroxyl radical by reducing UV radiation, and then affect the atmospheric oxidation capability, which can also affect the formation of secondary organic aerosol or like secondary inorganic aerosol. And also the chemical compositions of brown carbon conifers can also affect the human health. For example, the constitution of the brown carbon could be PAH, humid-like substance, and biopolymers. And I think the essential part of this research is the optical properties, such as like absorption Armstrong exponent and mass absorption efficiency. It vary greatly depending on the sources and chemical composition. That's why we carry out this research. So this is the current status of air pollution in Taipei, which is this one. Although the PM 2.5 concentration recently is decreasing due to the air pollution control by the government, but it's still like higher than the WHO standard, which is like 2.5 times the standard. And also Taipei has the largest population in Taiwan compared to the other cities. So the impact of anthropogenic emissions, especially like traffic related sources on air quality or like regional climate, is even more significant. And what's more, of course, there's currently very little research on brown carbon in Taiwan. I'm not sure in Thailand, maybe. I think there is some research in Thailand based on the in situ measurement by, for example, like astometer or other optical instruments. But from this way, maybe I have to check from the reference, or maybe some of you have done some previous work. So it's necessary to carry out this research to understand the impact of brown carbon in this area, either on climate or human health. So basically, there are three main research objectives. The first one is I would like to attribute aerosol light absorption to brown carbon and provide the parameter of optical properties for the input of climate model to estimate the impact of brown carbon on regional global climate radiation. And also, I would like to identify the chemical species of brown carbon conifers and the sources of brown carbon to characterize its physical and chemical properties, and of course provide some mitigation strategy of air pollution. So brief experimental methods were given here. So the simmering site is on the top of a building of in the NTU and in Taipei metropolitan area, and nearby the several main roads. And the sampling period for like daily PM 2.5 sample is collected every 3 days. And I use the time period was 24 hours because the brown carbon is like only 20 to like a 50 or 70% to organic carbon. So I just prevent it is below the detection limit of the instrument. And the sampler is high volume sampler with quartz fiber filter. And this is the flow chart of the analysis of brown carbon optical properties. So yeah, a brief description of the method will be given in the following slides. So the extraction of organic carbon fraction, the portion of each sample was extracted respectively using ultra pure water and methanol under ultrasonic bath for 45 minutes and then filtered through a syringe filter. And then a portion of sample was used for the analysis of organic carbon, like particulate organic carbon and elemental carbon, applying thermal optical carbon analyzer following the improved temperature protocol. So as for the mass concentration of water-soluble organic carbon, we use the TOC analyzer to measure, but the methanol-soluble organic carbon cannot be obtained by TOC analyzer because its volatility and interference would affect the TOC detection. So, and the absorption spectra of water-soluble, I would say, like WSOC and MSOC extracts were determined by the UV spectrometer in the wavelength range of 300 to 700 nanometer. So this is for the calculation of the absorption coefficient from the absorption spectra derived from the UV detector. So I think, yeah, I won't describe the detail for each parameter. So I would show you like the apps at wavelength of 365 nanometer is used to represent brown carbon absorption in order to avoid interference from non-organic compounds. Basically, it will be affected by nitrate at shorter wavelength, and also try to maintain the consistent with previous study for comparison. And then the optical parameters, AAE, absorption answer exponent, and mass absorption efficiency were calculated by this equation. So basically, the mass absorption efficiency for water-soluble organic carbon will be used in the following discussion. So in order to investigate the relationship between primary organic carbon and secondary organic carbon and the absorption of WSOC and MSOC, the elemental carbon tracer method was used to apportion organic carbon to POC and SOC. So here, the ratio of organic carbon to and elemental carbon, the minimum of this ratio was observed during the study period were used in this equation. So here I want to show some optical properties and organic data. For the last figures, in general, the absorption of methanol-soluble organic carbon is higher than that of water-soluble organic carbon in the 3 seasons, which is spring, summer, and winter. And as you can see here, the quantity of the PM2.5 absorption, the PM2.5 mass concentration and absorption of methanol and the water-soluble organic carbon is largest in winter, followed by spring and summer. And in terms of the optical properties, the AAE for MSOC is the highest in winter, followed by summer and spring. However, the AAE for water-soluble organic carbon is highest in summer, followed by winter and spring. So it can be noticed that the optical properties of MSOC and WSOC show different like seasonal variation, indicating like brown carbon conifers of MSOC and WSOC consist of like chemical composition with different optical properties in different seasons. So I think it's essential to further characterize the composition of brown carbon to better understand like the contribution of individual species to light absorption and identify the sources, try to regulate it. So I think these are there are many like chemical analysis are still in progress. So the following discussion is mainly based on the winter and spring data. So as you can see on this figure, absorption for like methanol soluble and water soluble organic carbon for both seasons increase with like PM2.5 mass concentration organic carbon, water soluble organic carbon secondary organic carbon and the ratio of OC and EC and the portion of SOC in OC. So basically, this ratio of OC and EC was used to represent the agent level of organic carbon. So it also shows like a relationship with the absorption. So, but there's no correlation between either absorption answer exponent and yeah, I didn't put the mass absorption efficiency, and the above parameter observed as they strongly depends on the constituent of brown carbon conifers. So it doesn't show like the correlationship with the quantity of this parameter. So from the figures on the right, we can see that the WSOC accounts for like about 50% of organic carbon in winter, 41% of the organic carbon in spring. So it indicates that there are seasonal variation in proportion of WSOC. So the analysis of the correlation between absorption of MSOC and WSOC with organic carbon has shown
Excuse
that
me,
the absorption.
Danny, you have a minute to wrap up, please.
Yep. So both extract in spring and winter exhibit high correlation with organic carbon. Moreover, the absorption for MSOC increased faster than that for WSOC, with OC indicating that organic carbon quantity has more significant effect on absorption for MSOC compared to WSOC. So here you can see on the figure, so the y-axis is the mass concentration of POC and SOC. So the x-axis is the absorption for methanol and the water-soluble extract. So it can be found that secondary organic dominates the absorption of MSOC in winter, while POC dominates the absorption of methanol and water-soluble organic carbon in spring. That means like the seasonal variation in dominated organic carbon contributing to absorption has like differential impact of brown carbon conifer on optical properties. So here is some a table for the optical parameters comparison with previous study. So I won't describe it details, but as you can see here, the absolute absorption of like water soluble organic carbon is less than the others, but the optical properties of the brown carbon in Taipei is comparable with the other regions, which means like the brown carbon, the characteristic of brown carbon conifer in Taipei is still essential for the estimation of the absorption and also the contribution to the climate forcing. So here's some like identification case. This is the from February 25th, when the PM 2.5 is the largest during the sampling period. So and we have like identified several species, but the identification is still ongoing. So I just want to show you, like for example, like this detection time at like 8.26, which is number 2, and could be like this species contributing to light absorption. And the method to identify is to like the fragments of the mass weight and try to compare with the database and also the previous study. So of course, future work, there are still a lot of work still in progress. So hopefully you can have like some decent result in the future. So at the end, again, I would like to promote like the Asian Aerosol Conference next year. You know, it's like held by the TAAR, like Taiwan Association for Aerosol Research, and it will be hosted in the NTU. And I think TC is responsible for this conference. And owing to the pandemic, I think it's held as a hybrid conference, and our foreign participants are welcome to join our virtual meeting. And of course, feel free to pass this invitation to your fellow colleagues and students. And there's a chance for like Southeast Asian participants to apply for like registration waiver fee once they accomplish oral or poster presentation. Thank you. Thank you for your attention.
Right, thanks, Danny. Any comment or question from the floor, please?
Yes, may I ask some questions?
Yes, please.
Thank you, Danny, for your very nice presentation. We just start our analysis for the black carbon. We just got the new instrument, the DRI 2015. I think it's the same model, right? Yes. Just would like to know more about the brown carbon analysis. I did not catch up it exactly. How do you perform the brown carbon analysis? Do you use this DRI or you use another instrument for that?
Okay, I think for the extract, it's no problem for the extraction, right? For the extraction of the filter, and then use the extract to first, if you want to know the total absorption of the extract, you can use like UVVs for like the scanning at the whole range of the wavelength. And then if you want to identify the sources, not identify, I mean, no, let's try to separate different species. I use the HPLC and the DAD, which is photo diode with different wavelengths, like from 300 to 700 nanometer of the wavelength to scan the extract. Because the water soluble organic carbon absorbing the shorter wavelength light, then you can identify, you can recognize it as like brown carbon. And if you want to know the species, you have to do the high resolution mass spectrometry. Of course, you have to compare or like combining with the DAD analysis, try to know at which wavelength the species has absorbability at a specific wavelength. Is it clear or?
So it's quite complicated and oh yes, we can discuss later. Thank you.
Yeah, no problem.
So, may I ask a question?
Please, TC.
Yeah, hi, Danny. I think it's a good work and good story, and we see several interesting data. I only have one. I mean, I noticed actually your MAE assumption efficiency in the summertime is really low compared to the other season. I think the number is like a 0.4 something compared to the other two, right?
You mean absorption efficiency?
Yeah, absorption efficiency.
Yeah.
Yeah, this one.
Yeah.
I mean, compared to the winter and spring,
yeah,
the water soluble organic carbon, that one is,
yeah.
Although later on in your the summarize table compared to the other cities, the it's still within the range. But do you have any idea like here? Yes.
Yeah,
I think. Yeah. Go ahead, please.
Sorry, yeah. So yeah, I saw some references saying like for if the brown carbon from photochemical reaction is less contributing to light absorption compared with compared with the brown carbon formed by the oxidative reaction, for example, like heterogeneous or aqueous reaction. So I think in winter, even is mainly contributed by secondary organic carbon. I think this secondary organic carbon mainly formed by the aqueous reaction, but not photochemical reaction. So in the summer, one reason is the organic carbon, the amount of the organic carbon is less compared to the other season. The another reason is the formation mechanism of the secondary organic aerosol.
Yeah, the amount is less, but the fraction, I think in the summertime, the fraction of organic carbon could be.
Summertime, I didn't show here. So I think I only show like spring and winter, but it's comparable with the previous study. I think only like 40 to 70%. I think it depends on the reference or the region. Depends on the region. You mean the mass of the water-soluble organic carbon, right?
I just want to make sure one thing is normally in for example in Taichung, the organic carbon actually or the secondary one during the summertime is higher. Higher means in terms of fraction, not the absolute amount.
Okay.
So
yeah, I didn't show the spring because I haven't got the data from summer. So, but here, the winter, oh, yeah, it's less than 50%, but spring is about like 60, like 20 to 60% of secondary organic carbon.
and your efficiency is solely based on the mass of organic carbon or based on total PM2.5 when you calculate the efficiency. That is solely based on the organic carbon, right?
Yeah, based on the organic carbon. Yeah.
Yeah. Okay.
Yeah.
I
so
see.
That's why it's still comparable with that in previous study. You know, it's still on the range, and the reference saying like the agent, like secondary organic aerosol, if the brown carbon dominated by the secondary organic aerosol, then the AAE could be like 4 to 7. Then ours, even in Taipei, with the lower PM2.5 compared to Taichung, we are still like about 5 to 7, 8, something like that, which is much close or consistent.
Got it.
Yeah.
And the MA you calculate it just using the data from both. I think you need the assumption from a sonometer and the mass from the chemical analysis, right?
No, I didn't use the estimator data.
So you use the UVBIs?
Yeah, UVBIs.
Okay, got you.
Yeah.
Professor Win, please.
Hi, Danny.
Hello.
Thank you for your presentation. I have a question in order to think in terms of like collaboration. I think about the potential to model brown carbon in the model because organic carbon, like water soluble organic carbon, for example, already exist in the model. But in order to model them, like we would need these optical properties of the different emission sources, right?
Yeah.
So what you show here is the data of these optical properties of the sampled organic carbon, right?
Yeah.
So is there existing optical properties related to different emission sources?
Yeah, sure. I mean, as I said, there are like chemical analysis, for example, like trace elements and also like cation, anions. With this data, we can do in like PMF to identify the sources and including, and then when we combine the brown carbon properties into the input of the PMF, then we can know different properties of sources. Yeah.
All right. So that would be interesting potential works.
Yeah, that would be interesting to if you can include these findings or this result into your model. Then yeah, I'm very interested in like seeing how it works, you know, compared to the modeling and the data from the field work. Yeah.
Cool.
Thank you.
Thank you.
All right, thanks, Danny, for the impressive work. I'm positive that the optical properties of black carbon would be much interesting among this group of researchers for further discussion. Okay, if we don't have any question from the floor. Okay, thank you everyone. We appreciate you being here and thanks again for joining us this session. And the next session chair will be Danny. And sorry guys, I have to run to host another meeting at 10:30. I may be jumping at the end of the conference. Okay, thank you. I will pass
Thank
the
you.
floor to Danny, please. Thanks.
Thank you, Professor Uma. So should we have a like short break for 10 minutes? It's all right. Yeah. So we'll come back at like 10:45 in Taiwan time, and Thailand time is 9:45. Thank you. twist. So I want to introduce Marge, and her topic is what else are required to tackle PM 2.5 in Thailand. And I think she has another conference to host. So she provides the pre-recorded video. I will play for her.
Thanks to the organizer that allow me to present as on video clip. Hope you are all well and stay safe. If possible, we could meet each other at the Asian Aerosol Conference next year. My topic may be different from yours, but I would appreciate it if we could discuss more on air quality issue anyway. I will talk on TAQM and what do we need to reduce PM 2.5 in Thailand. On behalf of TAQM, I should introduce part of this project before starting my topic. The purpose of TAQM is to gain a sustainability of clean air using the network of related agencies on air quality, both in and outside Thailand. Then we have focused on knowledge transfer, sort of knowledge theory, technique, hardware, software, etc. on sustainable management of air quality for local communities, government agencies, private sector, the industry, and the education sector. For those who are in air quality field, you would rely on this cycle basically. Likewise, the TAQM activities have been set up to convey the same step as a scientific research project in the middle of the cycle. TAQM management of good air quality or clean air. In this slide, you could see the 4 stems of activities along our work, which are monitoring, analysis, research, and development part. The output of the first activity on monitoring is low-cost sensor, including the publicly available data platform of the sensor network. We have also done analysis and research activity. The concept of our research mostly based on circular economy, and the most important, they should be easily implemented by policymakers. Finally, the output of development part includes raising the public awareness. That's why we have continuously published articles on TAQM website, of course for Thai people in particular. Moreover, we have involved in many projects of pollution prevention and control technology. We do hope that the outcome of TAQM project more or less will lead to those related SDG topic as well. Slide number 6 to 8 are examples of TAQM activities recently. This is the publication of monitoring work that we have been done since 2016. The first model in Thailand of sensor network installed in Nan province by our team that supported by Thailand Research Fund. This is sort of research on remake and redesign project. We were asked to reduce the air pollution released by communities of electronic waste recycling system. For Thai people, you may know where it is. Well, even Thai government have regulated the e-waste, but the gap of law is still there. Those local people don't have any technology, and the cheapest way to get copper from the electrical wire scrap is, you may guess, yes, burning. So the challenge is engineering simplification of device, such as all materials have to be easily found in the local area, and we have to convince them to use our equipment. This part was actually harder than have it built, I would say. This slide displays another equipment in the same project of remake and redesign of waste utilization. Apart from electrical scrap, then the PU foam as air filter, and the communities use this as air cleaner in their house. As mentioned earlier, public awareness is important in air quality management. A number of articles then being provided in TAQM website, not in technical language, but in common understanding way in general, but still keep the crucial context. So that's all for brief introduction of TAQM. You could learn more on TAQM and my work along with these addresses. This is my topic. What else are required to tackle PM 2.5 in Thailand? My co-author is Professor Thongchai Pansawat. As we are in air quality field, the common question is what's the origin of PM 2.5 in Thailand? Then I prefer starting with the map of Thailand. Here showing the variation of source and peak season in each region of our country. You would hardly see the beautiful scenery of the northern part of Thailand during March to April more or less. This is because the forest fire and open burning, also transboundary haze, will cover the area. For the capital city of Thailand, Bangkok, is affected by traffic congestion as informed. Meanwhile, the PM 2.5 covers the eastern part by industry activities. The graph at the right corner here is the annual mean concentration of PM 2.5 in Thailand since 2011 of each region in Thailand. The red dot line is the Thai standard concentration at 25 microgram per meter cube. In general, all parts as a whole still exceed the standard value, as you can see. If you could notice the peak season in each part of our country, you would see Thailand have been blanketed all year round. This is the chart we have circulated to those related in solving air pollution. We have identified correlated groups of different functions and responsibility who together as a team can mitigate the problems. As displayed in the figure, the suggested players start from sufferer, polluter, rectifier, and public sector. Those who cause the problems are obviously the ones who should take the responsibility. Although a national roadmap to solve particulate matter pollution in Thailand has been released, they are only technical issues and are not sufficient. Here I will mention on some players in the picture, which are incentive provider and researcher. Incentive provider. There are two other additional measures that are likely to be taken to deal with PM 2.5. They are fiscal and commercial measures, such as financial support to public sector, especially local farmers who consider agricultural burning the most effective and cost-efficient way to clear land, fertilize soil, and prepare it for the new plantation. So, we should have financial support to them to create tools and harvesting equipment using their own appropriate technology and enable them to have their equipment replaced at lower expense. Next is researcher. As you see on the figure, these all aspects are interrelated. However, it is far too complex for any individual to completely comprehend. It should have academic unit including thinker, technologists, social scientists, lawyers, economists, environmentalists, etc. to share their viewpoints and take issues at least from number 1 to 14, not just emphasizing engineering measures as currently done. You could read more in detail via this short URL. For sure, Thai government keen to tackle the situation, but why it seems that nothing has been done? Well, those from developed countries who overcome this issue know that it's not as easy as they think, or presumably asking for a favor from polluter, please stop polluting the air, right? In my opinion, the pain points in Thailand that slow down the solutions are firstly, knowledge is scattered around. How could we get them together and solve the problem at instant? Like having this kind of forum to exchange information of academia, for instance. What kind of knowledge we need? We need a lot of information and fact to beat air pollution. For example, in Bangkok and other 5 surrounded provinces, so-called Bangkok Metropolitan Region or BMR, still need more research and detail on what's going on during the peak season of crisis. What and whose is the most polluter? Well, it doesn't mean we don't have any clue, but we need more evidence to emphasize what the actual sources are. Well, we have to beat the air pollution regarding the limitation of budget and personnel resources. So we have to tackle the main one, in particular during the crisis. Secondly, Thai Pollution Control Department or PCD, who is the first name being mentioned on PM2.5 crisis every year. They are working hard under act, not law. Then they have only asked allow for a favor to stop polluting the air. And come to the next point, that managing a variety of polluters requires a lot of related sectors to get along and setting their objectives and key results that stay relevant and applicable. What I'm gonna explain is the related sectors not necessarily to set their key performance index as PM2.5 reductions and judgment of their success, but they better know what and how to act on reduced air pollution according to their position. The last but not least, the local government are required to take action more and in detail. Of course, the central government should give them the practical protocol continually updated. Sound hopeless? Yes, but I myself found that the PM2.5 situations have made Thailand a turning point. First, we have the National Action Plan on Dust Reduction 2019 to 2024. Second, more research funding available. For example, the National Research Council of Thailand have increased the grant on PM2.5 in 2020. The grant was $5 million. In comparison to that, in 2017, just $800,000. Also other grant agencies that makes the development of science and technology in Thailand rapidly jump and certain. More interestingly, PCD have been developing the new emission standards since January this year. We will see the level of 35 or 37 microgram per meter cube as a new daily standard of PM2.5 in Thailand, even though it won't be close to the new guideline of WHO, but it's a good sign of Thai people, because the existing one is 50 microgram per meter cube. Below here, which are research areas that TAUM have involved, and we hope to deliver the appropriate results to the funding agency soon. All explanations I mentioned here is the magnitude of crisis is leading to increase the awareness both citizens and government. In my talk, also stress that what else Thai government require as supportive techniques to tackle the air pollution crisis. And I would like to conclude that the technical issues is important, but they are not sufficient. Other items for integration and supportive political will also meaningful and be needed. Thank you for having me involved in this forum. It's my honor to exchange the issue of air quality management here. I do appreciate all the hard work that NTU have done to set up this Taiwan and Thailand Air Quality Conference. And thank you all for participating in this forum. We do hope that you are enjoying and gaining more network among researchers and professors. Looking forward to see a new challenge of air quality, modeling, aerosol, and climate research soon. Thank you.
Oh, many thanks to Professor Sirma. I think she's not here, and I think she gave very broad and also impressive the air pollution issue we face in the future, or like a technical problem we face now, and we have to tackle with it for 2.5 or for like air pollutant. So if you have anyone has like question, and we can discuss offline with Sirma. So next speaker is Professor Xiao, which is also working in NTU, and I think he's very good at like aerosol pollution control and aerosol instrument and PM2.5. Everything. I think he's quite has a lot of experience in field work and also some modeling techniques. So let's welcome Professor Xiao.
Thank you for a kind introduction. I'm going to share my screen. So can you see my screen now? Okay, great. Before I start, I still would like to invite you all to attend the 12th Asian Aerosol Conference. There is a QR code. So if you need further information, you can use this code to take a close look of the webpage. It will be sorry, the day is a little bit wrong. It's supposed to be like June 12 to 16, 2022. Sorry, the day is not correct, but definitely in Taipei, National Taiwan University. So please try to join us to attend the conference. It's the biggest aerosol event in Asia. So today I'm going to talk about the visibility and aerosol optical property in Taiwan. Some of the material actually is what I have presented in last Asian Aerosol Conference in Hong Kong. And my name is Tachi, you can call me TC. And I'm from Graduate Institute of Environmental Engineering, National Taiwan University. And thanks all to attend this conference, and thank for the organizer, Professor Danny Eating Ding, to organizing this great event between Taiwan and Thailand. So brief introduce myself. I'm working on the PM2.5, PM1 ultrafine particle and atmospheric aerosols, and I split 4 different kind of direction: nanoparticle generation and physics. My research is more focused on aerosol physics and mechanics, and I do a lot of atmospheric modeling and apply those information for health risk assessment, like Sapon did before. I mean, in the first presentation. And of course, after that, we need to propose sometimes the control technology to or eliminate or elevate these air pollution issues. And we also work on aerosol and cloud microphysics, but that is not today's talk. And I thought Acharya here, and we both graduated from Washington University in St. Louis. Okay, we are alumni and we're proud of WashU.
Yeah.
So great, and welcome. You have a time if you have time to visit Taiwan. I'm more than happy to introduce my work, my lab, the modern science, etc.
Okay,
So,
I will.
Great. I mean, hope to see you next year. And here I just briefly give you some background information. I think not just only air pollution, but air visibility is another important like visual feeling about air pollution. And here is some statistics in Taiwan. You can see we just mostly focus on the central Taiwan, Taichung, in past few years. And this is the statistics. You can see the human visual range actually increased a lot, at least 20%, but up to now actually like a 30 something percent improvement you can see in the past 10 years. And pin-to-point flight actually decreased a lot from 30 down to like 20, but even down to like 15 recently, microgram per cubic meter. So, but still, we don't really feel, I mean, from the public perspective, we don't feel that much improvement. We still do not feel good enough, I mean, in terms of visibility sometimes. So how can it be? Here is just some statistics show those improvement that is objective. I think it's more objective. But so that the motivation here is a research scheme. I think we start from, give me a second. Here, here, visibility impairment, that is an issue. I think there is a science behind it, or also scientists know like RH or particle size distribution, chemical composition, all can influence on the visibility. And Danny did a research on radiation forcing. Those is the vertical way, I mean, the optical property, how to influence the radiation in the vertical zone or in the vertical dimension. But visibility is in the horizontal dimension. How does this particle influence the light transmission? So after we know those signs, of course, we try to suggest some policy. So we try to find what is there any new emission, or is that due to like land use change or heat island? Recently, climate change COP26 is really hot, and or some long-term effect like boundary height change. So those are related to the policy we supposed to give them for the government based on the size. So what is the size? Here is the data I'm going to show from past, I mean, like 2017 to 2019. And here is just trying to let you know what is the site look like. Actually, I have two monitor size data here. And quickly, there is a monitor station we call the impact integrate measurement of pollution and aerosol composition and transformation, include several different kind of instrument in one trailer. We learn from NASA and try to build our own monitor. The mobile monitoring station include those chemical analysis as well as some aerosol physics measurement. I think some of you might use this instrument before. If you have any question, we can talk about this later on. So back to the more things. Silvermar is not here, so he gave me more like 10 minutes, right? So I can talk about more detail about these equations. Those are detailed, like Kashmir relationship is the reciprocal relationship between the extinction coefficient and visibility. Actually, you can see here, you can multiply the distance with the coefficient of extinction or extinction coefficient as a constant. So they are reciprocal, means if you have a lower visibility means higher extinction coefficient. That is the general way we use to determine sometimes particle concentration, but that is not totally true. I mean, they are not one-to-one, not linear relationship. That is the point. So if you want to take a close look at equation, welcome, but I just try to like show few things. Like here, the light is attenuated by the particle, mainly, but not only. It can be attenuated by the gases, but in the atmosphere, mostly just due to the particle there that cause extinction coefficient that causes and we focus on particle again. And there is two mechanisms. One is absorption, the other is scattering. And there is some detailed formula can be used to calculate theoretically. But I think the point is there is some concentration effect. You can see you have to integrate all the particles influence into to get the overall effect. So you have to consider, but that is not one-to-one. Actually, it's more related to the cross section. It's more like a shadow. But since the particle is so small, it's no longer like one-to-one. You have to multiply by some constant. That is here is a Q. And the Q is a function of refractive index, which depends on the chemical composition, or we call material dependence. And also the fraction, the cross-section area is size dependent. And combine these two and also the numbers, and you can get the total influence. And however, in the ambient case, size dependence is also depending on material. Why? Because there is a particle growth. So if your particle is more hygroscopic under the high relative humidity, it can change the size. But the mass concentration you get normally just a dry one. So that is, you don't really consider the RJ effect in the ambient. And previously, like Danny presented MAE or MSE, that is the per mass efficiency. So it's normalized by the particle mass. So that is a capability, or the I always use that is the intensive property, which normalize the mass per mass unit. So when come back here, just demonstrate here is the extinction coefficient. The higher one means lower visibility, and so reciprocal means you can see that the behavior is more like this. And I based on this 2 years data, we set a criteria like a 200 as a bar. If that is even higher, then that means the event case was the top 10% worst case among all. If your lies the coefficient of extinction coefficient less than like 40, then that means a clean, extremely clean case. And you can see the extinction coefficient actually is influenced by or correlate. You can see the behavior, the SSA, single scattering of beta, means if you have a very low visibility, high extinction coefficient, then normally it's dominated by scattering, not absorption. That is the first thing. But since the limit of time, I don't want to get to the too detail. The point here I want to show in the long-term observation, you can see actually the PM1, PM2.5 concentration actually changed. In 2018, actually, we have a lower concentration already. But here is a two different kind of figure. This is after conditioning, means that is the dry PM mass concentration. We also measure the ambient one. We just remove some dryer, and so this mass concentration is actually represent the ambient case, not the dry case. You can see higher, and also fraction is different. Next slide, I'm going to show the PM1 to PM2.5 fraction. And here we also have a OCEC and BC value, and I skip that one. And here, the interesting part is, although we have a lower mass concentration in 2018, however, the PM1 concentration, doesn't change it that much. It also decreased, but doesn't change it that much, which will result in the higher fraction of the PM1 among PM2.5 in 2018. And what that happened and what is caused like that. Later I will demonstrate actually the visibility is a strong function of PM2.5 already, but it's not only PM2.5, it's also a much close related to the PM1 compared to PM2.5. Otherwise, we are supposed to observe a great improvement on visibility in 2018 after summer, but that is not the case. So one is that they come to the the main point I want to address for this study, that is how does the visibility relate to the aerosol optical properties? Here is a seasonal variation among 6 different seasons. We group into 3 groups based on, you can see type 1. This is a cumulative probability function. So the 6 season we can group like the type 1 is the best visibility case. I mean, in terms of total cases. And the third, you can see is the worst one. So the 4th season we group into 3 different kind of types: good, clean, bad, and worse. So here I think come to the first one. So why the PM reduced, but visibility is not that much improved. Sorry. In other way to say that is the ability of PM to scatter light per unit mass, that is mass scattering efficiency, is getting stronger. So here we investigate the mass scattering efficiency, that is sigma s divided by PM 2.5. So as you observe, the high extinction coefficient is not only resolved by high PM, but also due to the efficient mass scattering efficiency. During the high B extinction period, that is event, it is found nitrate fraction is high and particle size based on the that is shorter mean size is based on the surface weighted by surface area is relative large. From the later here, you can see here actually the lower one, the color becomes more blue is that fraction of the sulfate. In other way to say that the higher fraction of the nitrate. So here you can see the size change actually accordingly at that from this figure. By the way, the higher MSE in summer could be attributed to high OM fraction and some C. So I skipped that one. Probably only have 10 more minutes to go. And next, so here you can from type 1 to 3. And on the left-hand side is a clean case. On the right-hand side is the event 1. In between, I split into like a 3 figure. You can see I try to quickly explain that the x-axis is all scattering coefficient, and the y is a fraction, and the color represent a different kind of composition. Here is a nitrate, and here is OM. Here I use red represent the sulfate soil and a sea salt. But the most significant behavior, or you can see from the left hand side means from a transit from clean to event, the nitrate increase a lot here. So, but that is not a really new news right now. In the paper, people always talk about the nitrate issues in the past 5 years for the Asia countries. But I think it's still worth or good to know and see this pie chart. And for the O clean cases, the major contribution for the B scatter are OM and sulfate. But for all worst cases, nitrate has become an important and non-negligible player. And second, it is also can be observed from transition behavior. So in the figures, sorry, where is my? Oh, okay. In a figure in between, and in general, OM contribution is decreasing as scatter increasing. However, for the type 2, even in the worst 10%, OM still remain 40% portion of the B scattering means. Actually, OM is the organic matter is important, like Danny presented previously about the brown carbon. And they are not really exchangeable, but relate to each other and also relate to the pH. So I think that this is the, really a busy slide, but I think it's important. If you can take a closer look at this slide, I try to explain within like a few minutes. Let's look at the MSE again in more detailed way. Here is a color code to represent different parameters we investigate, and those are known to be related to MSE. Left two columns are related to aerosol physics, and here the left one, these two are related to aerosol physics, and these three are related to the aerosol chemistry, the chemical component. For the case for type 1, take a look at the row of the first row. 2018 summer, the distribution of MSE is a Y shape. There are two truths. And the low extinction coefficient but high MSE always correlate with high OM, while the other truth is dominated by sulfate. As MSE increase, PM1 fraction and the shorter mean GMD both gradually grow. And for that is first phenomenon. For the type 2, for the chemical contribution, nitrate is definitely an important factor for the high B extinction and low visibility. Again, high B extinction means low visibility. And other than this, the shorter mean GMD is corresponding to the high MSE and B extinction as well, while influence of PM1 fraction is not very significant here, probably due to mixing the 2 years, 2018 and 2017. What I want to say, just remember in these 2 years, the fraction of PM1 a little bit different. In the 2018, they increased the fraction of PM1. So I think that is one of the reasons we don't see a significant role of the PM1 fraction here. And this implies that although the cumulative distribution are similar for a seasonal characteristic in type 2, but they could be resolved by different causes. For type 3, the effect of PM1 is clear and well correlated, actually is pretty strong. However, the effect of particle size is not that it becomes blurred. And or the trend is even opposite to previous 2 types. This is because the particle may grow too large. I think so. And I think in the right column, the chemical composition observed obviously more important than the physical effect here for the type 2. The main contribution to B scattering or the extinction coefficient transit from OM to sulfate, then nitrate. I mean, the color is like beginning here is stronger and transit, like give a hand to sulfate, then sorry here. Sorry, I got the OM is here is more important. Later on become the sulfate dominate in between transit, and last is the nitrate. So it's like a grow here, then different composition dominate in different region for this type 3 case. A shaking hand. So I think it's important to further illustrate the size effect. I stop here a little bit. So the point I want to address is the visibility become worse is not just because higher concentration, it's also because those particles are more efficient to scalar line or to extinction line. But why? That is related to particle chemical composition as well as their physical characteristics. What does the physical characteristic mean? That means the particle size. One of that is particle size. Here I demonstrate the particle size effect. When the size is close to the accumulation mode, then those are very efficient to scatter light. You can see the scattering becomes, I skipped that one. Anyway, the correlation here, if we change the size range to do the correlation, for the particle reside in the range between 100 nanometer to 1000 nanometer means 1 micron are highly correlate with scattering coefficient compared to the other size range. So this suggests actually those are good light scatter I mean, in terms of size aspect. So next, here again, to further elaborate the influence of particle size on visibility impairment, the average size distribution for event case and clean case were plotted separately in 4 time period in a day. Here, this is a size distribution, but that is a clean case. There are 4 isolated into 4 time: morning, noon, afternoon, midnight, and this is size distribution. And the red one or the brown one means the event case. The clean one, the size distribution is more like this: is in terms of particle number concentration. And this dashed line is a ratio between these two. So you can see we call it enhancement or enhanced fraction. So you can see certain size actually grow a lot. So the red dashed line is the ratio between these two. And you can clearly see during the event period, the particle in the size range between 100 to 400 nanometer grow dramatically here. But later on, when we combine with APS measurement, you can see a huge grow up here. But I don't show the data here. But even using the SMPS data, you can still see there is a 2 peak growth in like around 100 nanometer and around like a 400 or 350 to 400 or 300 nanometer to 400 nanometer range particles grow dramatically. And the geometric mean diameter ratio of event to clean is about 1.5. The interesting phenomena, is the lowest concentration is due to during the noon for event case, but for a clean case, it is time to observe the high particle number concentration. There is another thing. That is due to the low wind velocity, actually. So here, let's move the gear to the effect of meteorological factors. We try to demonstrate the efficient MSE is nearly linearly correlate with fraction of accumulation mode. And the fraction of accumulation mode is also related to ambient related humidity. And although it's not so significant in terms of the figure I show on the left-hand side, but if we calculate, then you can see definitely they have some large effect. And during the event period, the environment temperature is always higher than of the clean case, 2 to 3 degrees C higher. You can see here. That is event meteorological statistics. This is a clean one. You can see for the whole period of time, you have to compare morning to morning. You can see always during the event, the temperature is a little bit higher, and the humidity is not the case. During the daytime, the humidity is lower. However, during the nighttime, for the event, is higher than the clean case. That is statistics tell us. And the wind speed is generally low here. During the event, you have to have a stagnant weather condition to accumulate those material, accumulate the precursor and also accumulate the particle mass. But except the noon one here. So I think those low wind speeds suggest low visibility, high extinction coefficient, maybe resolved by local pollution, not much due to the transport, but the precursor can come from the other places, but a lot of reason is due to local emitters. And high humidity are only observable midnight in the morning for the event cases. During the daytime, the humidity is actually low. I think those are related to the heterogeneous natural NOx chemistry during the night. So I skipped the one. I almost used up my time. I think there is a few things I would like to say, but I don't have much time to close to finish them all. Here I just show not just only the important, next question we are going to ask is why they increase the efficiency. First, I give you the explanation due to the fraction of the nitrate and the particle size. But why is the particle size grow up to certain size that is cause the efficient light scattering? That is due to the nitrate accumulation in certain size. So you can see, and where does the nitrate come from? They come from nuts, and they convert from nuts to nitrate. So you can see the NOR, which is the uh, conversion rate from NOx to nitrate, is dramatically higher during the event case. And of course, you can see that the NO2 or NOx is also higher during the event case. So but the ozone, essentially, you can see event case is clearly higher and show a clear diurnal pattern. So the anyways, the story is more like you have to have stagnant weather condition, then accumulate the precursor. But not only that, you still need some condition to activate or initiate the conversion from NOx, the precursor, then change it to nitrate. And those nitrate happen to accumulate in a certain size range, and suddenly just dramatically reduce the visibility, then probably next day, because you need some time to incubate this situation. And normally that is a previous day, daytime high ozone, nighttime high higher temperature and also high humidity. The next day you will see a very low visibility. And we see again, and we analyze a few data and demonstrate here. And here is some chemistry. I skipped that one. So, and the conclusion comes to the high extinction coefficient is not only resolved by high concentration PM, but also due to the efficient mass scattering efficiency. That is the parameter we use to explain the so-called aerosol optical properties. And high MSE is generally correlated with high nitrate fraction and the fraction of PM1. So PM1 is more important than PM2.5 for visibility impairment. And particle size could also play an important role on seasonal characteristics of aerosol optical properties. We try to demonstrate this point in different aspects using a different analyze method. And low wind velocity and higher temperature were observed for worse extinction, worse visibility cases. And obvious ozone diurnal pattern observed for high base extinction cases imply gas phase reaction in daytime could be important, but in the high humidity at night also important for heterogeneous natural NOx chemistry. Okay, sorry, I run out of my time a little bit, and I would like to thank the financial support from Taiwan EPA and also support from Taichung EPB. And we also like to thank Dr. Shichi Tsai in NASA for supporting the Comet Trailer Mobile Laboratory for this study. And again, sorry, I got the wrong date, so don't take a look at this part. Just try to scan the QR code and find these important days, and we'll call for abstract, and hope you can contribute some of our abstract and attend the conference next year in Taiwan, Taipei. We are preparing to host you all, although there is a lot of uncertainty so far. But really, we would like to see you all in Taiwan and attend the conference in Taiwan, Taipei. National Taiwan University welcome you. Thanks.
Thank you, TC. Thanks for the very impressive presentation, and a lot of work has been done. So I think due to the time, we just, if anyone has question for TC.
Can I?
Yeah, sure. We open the one because of the time is.
Thank you, TC.
Yeah, it's okay.
It's impressive as always. I'd like to ask something, but maybe not exactly what you have presented. I would like to ask for your opinion about how about if we collect the PM1 and PM2.5? Sorry, we collect the PM1 using the different types of equipment. Can we compare them together? For example, I use the PQ200 to collect PM1, and then use the mini volume, the Ametrix one, to collect the PM2.5, and then I calculate the ratio among them or compare the mass because we don't have enough PQ200 to collect two sides of these particles at the same time. Do you think that it's reliable?
I think I don't know if that really reliable or not, because it really depends on several different kind of factors. For example, like how do you or where and when you apply the instrument. So what I can say just you can characterize your it really depends on uh, the performance of the size selector first, because you want to collect different size, right? So there are different size card. So make sure your size card is correct and operate under the right flow rate. During the sampling time, you have to make sure your flow rate are all correct during the time you do the filter sample. The other thing is you have to put in the same place identical, at least close, but not that close, because if you flow rate can, the sampling flow can interference each other. I mean, two sampler, if they are located too close, then the sampling flow rate can interference each other, and that is not a good case. But of course, I think you have a case K impactor, like you demonstrate for the PAH case. Then you can calculate a fraction based on the cascade impactors data. I think that is one easy one. And the second one, I think the optical particle sizer, or I think the one you demonstrate, the sampler, I believe they equate one chip optical. I don't say that is sizer, but they provide some optical signal. You can try to use that to estimate European one fraction also. They provide this kind of function, I believe, the ARM sampler or something. That is all so far I come to my mind. But if you have another question, we can discuss later about this problem. Thanks.
Thank you very much. Yeah.
Thank you, for TC and Sapon. I think we have to move to the next one. So the next one, the speaker is Professor Shi, is also working in National Taiwan University. I think his research interest is quite extensive, including like air pollution control, VOC control, recovery, and waste, like poisonous waste recovery. So I think we give the time to Professor Shi.
Professor Xu, you have to turn on the microphone. You haven't turned on the microphone. It's mute.
Thanks, TC, for remind me. Yeah. So is that okay for my voice? Okay, great. Thank you. So yeah, it's my honor actually to be the final speakers during this morning, talked about my research. And the topic basically is removal of the VOC using a very unique activated carbon. We call the bead activated carbon. And the focus I'm going to present today is basically on how to regenerate the carbon for those carbon has been saturated by the VOC. So it's my honor to be here and just quickly talk about my research interest and orientation. Actually, I define myself as a material guy. Actually, I prepare a lot of different kind of material, especially adsorbent, and using this kind of absorbent in air pollution control, water quality, waste recovery, and also in soil remediation. So, well, actually, I did a lot of stuff, not very, specific on one topic. And the topic I'm going to talk about today is about the VOC control and recovery. I think this topic is pretty correlated to most of the expertise today's we talked about. The reason why is because the VOC has been known not just is a carcinogenic material to the human health, but also it can be a significant precursor for the particular matter for the PN, not just PN 2.5 and also PM1, and also is the precursor for the ozone regeneration, okay, with the nitrogen oxide. So how to control the VOC emission is basically a big issue all over the world, and especially in Taiwan, because we have very strong semiconductor industry, and they emit a lot of different type of VOC. And why today's talk I focus on the adsorption, and then we put more attention on the regeneration. The reason why is because I put some sentence here, the keys in adsorption to success. Basically rely on two parts. The first part, of course, we want to make our adsorbent, and most cases in Taiwan, we use the activated carbon to capture the VOC. We want to make the carbon with very nice adsorption capacity, and also it can capture the VOC in very fast speed. So that means it has to have very nice kinetics. And also we want to enhance the desorption and the recovery efficiency. So if the VOC is in high price, we would like to recover it and reuse it. If not, we would like to desorb it, and then we can do proper treatment, and also the carbon can be reused. So the key part, not just to develop the carbon with very nice adsorption capacity, but also how we can success to regenerate the carbon, to reuse the carbons, to make the whole process as smooth as possible. And the key issue right now in Taiwan's industry using the carbon is basically relies on the magnitude of regeneration degree. So traditionally, even up to today, I think 99% of the companies in Taiwan for pollution control, they're using steam to regenerate. Well, we have to be honest, using steam to regenerate the carbon has much more advantages than disadvantages. But the steam, well, the biggest disadvantage, or let's say the drawback, is basically it has less efficiency, and also the water molecule may accumulate inside the pore structure of the activated carbon, and that is the part, and that is the space that we have to use to capture the VOC. So that means if the water cannot be successfully regenerated, let's say it can be skipped out of the carbon inside, then the carbon will have much less adsorption capacity in the next round. So we always try to find a better ways to regenerate the activated carbon instead of using the steam. So what we are thinking about is using the microwave. Maybe 10 years ago, people don't think the microwave can be used to regenerate the activated carbon. The reason why is because it is not easy to develop a large industrial scale microwave devices that we can put the activated carbon into, and then to make activated carbon successfully release as VOC. But as far as we know that in recent years, the microwave oven can be produced, can be established in quite a large size. I mean, industrial size, they could put significant amount of carbon into for regeneration work. So it's getting more and more to reality that we can put the carbon saturated with the VOC, put into the microwave and heat it up. Then if the carbon can be successfully regenerated, then the carbon can be reused, and the optimum goal is we can also recover the VOC to reuse. So the biggest advantage to using microwaves is because it's internal heating effect. So that means it heat from the inside of the carbon. So the energy efficiency will be much higher compared to the steam, because the steam is providing the heat from external. So that means it provides the heat by conduction, and that will result into more heat loss, and the energy consumption become much larger. So that's the reason why we think the microwave regeneration is a very good candidate to not just regenerate the carbon, but also to recycle the VOC if the VOC will not be disconstruction by the microwave heating. So for this research, actually conducted by one of my master's degree students has been graduated. And first of all, we try to establish the equilibrium and the kinetic maximum. And we choose two different types of VOC. One is toluene, another one is methyl ketone. The reason why we pick these two kinds of VOC is because one is highly hydrophobic, another one is slightly hydrophilic. So we can compare the affinity for these two VOC to the bead activated carbon. And then we try to find out the effect of the microwave power output and the irradiation times on the regeneration of standard BAC. And finally, we try to identify and report the effect of regeneration heat on the heel buildup. Okay, maybe most of the audience here is not very familiar with heel. The heel means the residual VOC or any other impurity presents inside the VOC that just cannot be get rid of, cannot be evacuated by the typical regeneration process. And the heel can be contributed by two parts. The first part, just like we say, the VOC just present in the very deep inside of the micropore. You just cannot take it out. The other one is during the regeneration or during the reabsorption process, the VOC decomposed. And a lot of time, in a lot of cases, it paralyzed, become the black char. So it just blocked the pore and results into a permanent decrease in the absorption capacity. So that's what we call heel. And typically using the steam, the heel can also contribute to the water vapor, the water molecule presents inside the pore, they cannot get out. So how to decrease the heel buildup is also one key one important issue is that when we try to do the absorption regeneration cycle and to make this process successful. So this is the three objectives we would like to discuss in this research. So this is the basic framework. First of all, we try to obtain one commercial bead activated carbon is Karuha activated carbon. I'm going to introduce that later because this one's really important. And also we try to prepare our own bead activated carbon. We're using the phenol formaldehyde resin as the precursor, and using the traditional carbonization and the steam activation way. CO2 activation ways to prepare the high surface area bead activated carbon. And then we do the fixed bed absorption and the absorbent using the MEK and the toluene. And then we test the absorption in 3 different temperatures with a very wide range of in-that VOC concentration, because we try to understand the VOC generated in different industry. For example, like in the painting industry, in the surface treatment industry, the VOC can be really high. It can go up to 2,000 ppm by volume. But for semiconductor industry, the VOC can be really low. It can be lowered down to 100 and even below than 100. So we studied with the very wide range of the absorption and also obtained isotherm. So as we obtain the isotherm, we can do a lot of simulations. For example, like we can calculate the heat absorption. We can we can simulate the kinetics to understand the adsorption behavior. And by doing that, we can understand how this VOC can be captured by the beta activated carbon. And then we moved to the key part of this research. We do the microwave regeneration, and the microwave power is between 400 to 1,000 watts. And the irradiation time is between 4 to 12 minutes. So you can see that for microwave regenerations, actually the regeneration time is really short compared with the steam, because the heat effect is much effective compared with the steam. So why we want to use the beta activated carbon? I think maybe this kind of carbon are not commonly used in Taiwan, but in North America, for example, like in Canada, Ford company is a very large vehicle production company. They're using the beta activated carbons to do the VOC recycle. And also in Taiwan, we have several surface treatment, surface painting, and also the semi-industrial company using the beta activated carbon. It has some very unique property because it has very lightweight, so it's easy to fluidize, so we can capture the VOC in a fluidized bed arrangement. And also it's very strong in mechanical strengths, and it has very high abrasion resistivity. So it's really good for carbon, for the VOC adsorption. But the key disadvantage, what we have been observed this far, is that it has very high adsorption capacity, but it's very, very difficult to regenerate. And because this kind of carbon is very, very expensive compared to the traditional powder activated carbon, so how can we regenerate it become really, really important. So we also prepare our own activated carbon, our own beta activated carbon from another commercial company, but we have to keep confidential for business issue. So we try to prepare our own carbons to see can we have higher adsorption capacity, or we can regenerate even more smoother compared to the Karuha activated carbon. But no question about it, the Karuha activated carbon is the Japanese company has been prepared the best BAC so far in the market, okay, to the best of my knowledge. So this is the devices used in our lab, including the fixed bed furnace. We can do the adsorption isotherm here, and we generate the VOC with the adequate concentration range and at 3 different temperature. And then we're using the THC analyzer, or actually it's a FID based analyzer, to observe the breakthrough curve. And also we're using the microbalance to measure the weight change before and after adsorption of the VOC to understand the adsorption and the desorption behavior. And this is the microwave in my lab. It can precisely control the power level. So we choose 4 different power levels between 400 to 1,000, and the different irradiation time to understand can the microwave successfully evacuate the VOC out of the carbon, and also we can understand the heat buildup inside the activated carbon. So for the result, first of all, this is Karuha BAC, and you can see that the surface area is more than 1,000 meters squared per gram. So basically, it's a highly high surface area activated carbon, and with most of the pore in micropore range. So micropore occupy more than 90% of the total surface area. And for the carbon prepared by my student, actually we can achieve the surface area up to 2,000. So we can make the carbon become highly microporous activated carbon, and with very, very high surface area, it can go up to 98%. So basically, it is not difficult to prepare the beta activated carbon from phenol formaldehyde resin precursor. And then we run the adsorption isotherm between 30 to 50 degrees Celsius. And then we evaluate the adsorption isotherm using 3 different models, including the Langmuir, Friendlich, and also the DR. And fortunately, 3 of the model can reasonably describe the adsorption behavior. So basically, based on these three models, first of all, we can obtain the maximum absorption capacity. So that's what we say the equilibrium absorption capacity by this model. So using the model, again, we can see that no matter for the MEK and or for the toluene, the carbon prepared in our lab has better absorption capacity compared to the commercial chlorohard beta activated carbon. And for the toluene, basically has higher absorption capacity than the MEK. So that means the toluene is much more easier to form some bonding with the surface of the carbon. So based on the Langmuir isotherm, we can obtain the equilibrium, the maximum absorption capacity based on our experimental data. And for the DR equations, we can not just understand the maximum micropore volume based on the modeling result, and also we can understand the characteristic of heat of absorption. So using this kind of information, we can describe some of the absorption property or the affinity between the carbon surface and also with the VOC. So this is the isosteric heat absorptions based on our absorption data. So for the SBAC, this is what prepared in our lab. Basically, you can see that the heat of absorption didn't change a lot with the loading, where actual loading is the absorption capacity. So that means for the surface of the carbon prepared by ourselves, the energetic homogeneity is shown on the surface. But for the KBAC, no matter for the MEK or for the toluene, first of all, for the MEK, the heat of absorption has a little bit decreased with the loading, but for the toluene, the absorption capacity is a little, the heat of absorption is a little bit increased with the loading. So that means it shows more energetic heterogeneity for the KBAC surface. And then move to what we really focusing on is about the desorption. So no matter for SBAC or KBAC, first of all, increase the microwave power. Basically, we can increase not just the desorption efficiency, but also we can shorten the desorption time. And compares the SBAC and the KBAC, we can find out that the carbon prepared in our lab has shorter irradiation time, so that means they can be much easier to be desorbed. I mean, the VOC can be easily desorbed from the SBAC than the KBAC. So in general, basically increase the microwave power, we increase the removal efficiency, and also increase the power, we can shorten the desorption time, and also we can achieve more complete desorptions for both the SBAC and the KBAC. And then we moved to cyclic test. The cyclic test means we absorb the VOC first, and then we do the microwave desorption, and then we bring the microwave desorption samples to do the absorption first, and then desorb. So we take 8 cycles to observe how good is those carbon can be reused, can be regenerated, and how good is the removal of the carbon. So this is the KBAC result. So first of all, for the MEK, we can see that even though the desorption and the absorption result is fluctuated, it's common because we cannot achieve, or we cannot expect the result can be perfect for absorption and desorption. But anyway, we still can observe that for the MEK, roughly the desorption and the next round absorption capacity is quite close to its initial equilibrium absorption capacity. So that means for the KBAC, if used to capture the MEK, it can achieve pretty nice absorption and the desorption, and also again increase the microwave power and also increase the irradiation time, can achieve higher removal efficiency. But for toluene, well, basically it has a very strong benzene ring, and also it's easy to be paralyzed and forms the black char to block the pore structure. We noticed that after the first run of the absorption, the capacity starts to decrease. So that means some hill build up inside the pore of the KBAC. And that is not what we prefer to see, but unfortunately it happens. So that means for the beta activated carbon, basically if we use it to capture toluene, we can have pretty good absorption capacity, but we cannot expect it can be recovered to 100% of its original absorption capacity. The capacity always decreased like 20% of the total. And moved to the SBAC, again, for the MEK, even though the data is fluctuated, and sometimes the second round absorption capacity can be even larger than the baseline capacity. That could be because the external error, or maybe the MEK react with the surface area, react with the surface of the carbon to generate more pore. But anyway, the absorption, desorption can be still within the original line. But for the total desorption, this is really disappointing result is that for the SBAC using in our prepares in our lab, maybe because it has large amount of the micropore. So that means the total, first of all, captured by the micropore of the SBAC, and then during the microwave regeneration, it starts to pyrolyze, it decomposes. So the heel build up, and those heel basically is due to the form of the pyrolysis charge. So they just block the pore of the carbon, result into the significant decrease of the absorption capacity for the next round. And it getting worse and worse when the cycle number time is getting more and more. And then we also validate this result by measure the surface area. We can notice that the surface area starts to significantly decrease. So that means it's significantly the buildup of the heel. So let me make a brief conclusions about my talk. First of all, is that we can prepare our own BAC, and even though it's commercially confidential, but actually we can still say that the production cost basically will be much lower compared to the KBAC. So we are thinking about how can we commercialize this one and also prepare and provide this carbon to the industry in Taiwan. Anyway, it can be used to capture VOC very nicely. And the absorption isochron can successfully describe our absorption data, and we can use that to obtain the isosteric heat absorption. And that kind of data is important because that kind of data can be used to design the heat requirements for regeneration. And for microwave regenerations, the rate of the MEK and the toning basically is much faster than those desorbed from the KBAC. So still, using the SBAC, we can successfully capture the carbon, capture the VOC and regenerate the carbon. And the VOC desorbed from SBAC showed better performance and relatively small irradiation power and time. But the most unfortunately thing is that for the SBAC, basically we find out after a cycle test, we have a significant decrease in the absorption capacity. So that means that the high microporosity of the BAC probably results into decrease in the total absorption capacity over cycle. So we expect that for most of the aromatic ring VOC, we're gonna suffer from this kind of question in the same situation. So maybe for the SBAC, it is not that suitable to be used for the aromatic type VOC, and also it may not be really suitable to use in the microwave direct heat for regeneration. So this is basically my talk, and I'll be more than happy if you have any question wants to interact with me. So thank you very much.
Thank you. Thanks for SG's presentation. Is there any question or any comment? Yeah, Mr. Wings.
Hi, Professor Chi. I have a question because I'm wondering whether different VOCs would lead to different efficiency. Because I may not catch correctly, but I didn't know what kind of VOC that you use in your experiment.
Okay, two type of VOC used in my experiment. The first one is the MEK, that is the methyl ethyl ketone. Let me use this view graphs. Okay, the first one is the MEK, so it has a much higher dipole moment, so that means it has much higher affinity with hydrophilic surface. The other one is toluene, and this one is highly hydrophobic. So we use these two type of VOC, try to understand how hydrophilic and hydrophobic affinity could influence the adsorption of the beta activated carbon, and we do see some difference. Basically, some carbons can capture the toluene much better than the MEK. And I would like to talk about that is there is another professor in University of Alberta called Zahir Hasiso. He has a very nice cooperation with Ford Motor Company to help Ford to recycle their VOC from painting processes. And actually, he did a very extensive research. He examined more than, I think, 15 different type of VOC with different dipole moments to see how the beta activated carbons to capture the various type of VOC. And he did find out that the affinity of the hydrophobicity of the VOC can significantly influence the VOC absorption and also the regeneration. And the most important thing is that it can result into significant difference in the yield build up due to the char forming. Yeah. So yes, it do have some influence in that part.
My question.
Sorry?
Yeah.
Ask a question.
Good.
Thank you for Professor C's great talk. I'm now working on the carbon activated carbon and absorption, but I just curious. In one of the slide, the SPAC and KBAC, I think one contain more nitrogen, the other contain more sulfur. In terms of the chemical composition analysis like this, well, would that cause different kind of surface affinity? Because I think that is one of, or that is that a reason related to the like a BT result or high microporosity? That is the first question I have. The second one, I saw the desorption, the temperature effect on the desorption for the KBAC looks like it's not converged yet. Which means when you increase for the SPAC you produce by your own after like a 400 degrees C, then the curve look like already converged, doesn't change too much. However, for the KBAC, the curve look like still developing at that case. So any explanation for that one, and will that cause any problem? And for example, how to choose the proper temperature for the KBAC case, if that is the case.
All right, thanks. Thanks for TC's questions. First of all, regarding the nitrogen content, well, actually, nitrogen content, or let's say the nitrogen functional groups on the carbon surface, definitely will result into the different adsorption behavior for the gas molecule, definitely. And in this case, well, actually, I would say because the concentration of the nitrogen is pretty low, it's just 1% compared to maybe 0% of the nitrogen. So the influence, I would say it will be much smaller than the other component, for example, oxygen. And we didn't do the functionality analysis for this sample, and we cannot make a very clear conclusion on that part. But well, actually, if the functional group of the nitrogens in the activated carbon is, for example, like armine or amine, so that means it's not a heteroalkanes nitrogen inside the benzene ring, then it will highly increase the hydrophilic property of the carbon. So that means if we have a lot of amine or amine functional groups on carbon, it will be more favored to capture the molecule with higher dipole moment, such as the MEK. Yeah, it would definitely result into that situation. But for this case, I would say I would not put a lot of tensions in nitrogen. I will put more tensions in oxygen. Okay, this is the first question. And the second question is regarding, I think TC, you are talking about the heat absorption modeling result, right?
Yeah, next slide.
This one?
Yeah.
Yeah, I'm sorry, could you please repeat that question again?
Just based on this slide, you can see for the if we compare the SPAC and KBAC, the curve for SPAC seems like over, oh, so not degree C, for 400 watt, then curve like all converge, doesn't change too much beyond that. But for the KBAC, it look like it's still developing. It's not converge to like invariant curve. So look like higher watt still can be applied for the KBAC case. Is that true? And what caused the different behavior between these carbon for under different power?
Oh yeah. So well, I probably have to go through this data even more clear, more deeply. But well, briefly from this data, we can just I can just explain that for the MEK and the Telling desorption for the SPAC, basically not that significant. Is that when we have our microwave power more than 400 watts, basically most of the VOC can be successfully regenerated, or not just regenerate, they can be successfully decomposed. So that means it just come out and we just don't see anything inside the carbon. But for the KBAC, it's not that easy to get the gas molecules comes out from its structures, especially for the microwave power below than 600 watts. So it may be resulted from the affinity of the VOC with the carbon, or it can maybe result into the pore structure, and that is the part that we probably have to put more attention into. But at this point, we just can notice that we just can identify how easy those VOC can be get rid of by the microwave regenerations for two different kind of absorbents. Yeah.
Okay, thanks. I personally I feel due to the shape of the curve, I think it's more related to the structure. Yeah, because the KBAC, the 400 watt look like more flat and have a longer time.
Yes.
Yeah. Cool. Thanks. Thank you.
Thank you, Professor Shi. I think we exceed a little bit on the schedule, so I think it's time for lunch break, and we'll come back at 1, maybe noon in Thailand. And the next section chairman is Professor Sampon. So yeah, we'll see you in the afternoon. Okay.
Okay, see you.
Thank you. Thanks for attention in the morning. Yes.
from
Yeah.
the beginning.
Okay, welcome to Thailand then.
Yeah. Yeah. Very good place, and
Yeah. Yeah, hope you have a chance to visit us in Chiang Mai sometimes in the future. Yeah.
sure. Yeah, sure. Yeah, a good place in Chiang Mai.
Yeah.
For the
Have you been here
tourists.
before? Yeah.
Huh?
Have you been here before in Chiang Mai?
Yeah.
I see.
Good place. Yeah.
Yeah. Danny, have you been to Thailand?
When?
Yeah, when I was a child.
Sorry.
When I was a child.
Yeah.
Yeah. I hope after this pandemic, then I can have a chance to visit, of course.
Sure. You're welcome.
Yeah.
Now this
Also,
I tell everyone we have many opportunity to meet together because I held many of the conference, many conference here. So I think we will have many, but it's better not online. It's on site is better.
Yes. We have to wait for maybe a year. Hope so.
I'm not sure. Hope not. Hope not. No.
Yeah.
Maybe we soon we could meet on the AAC, Taipei, AAC, and we'll have a TNT and people said. This is for young student, young scholar, mainly for young scholar. Yeah. So just encourage them to meet together to publish their any article.
I think it's time now. I'm not sure how many
Right.
people
Right.
are
It's time. It's time already.
Yes. Just a moment, please. I just check how many of us already here.
13.
So could you please turn on your maybe camera for the one
Already?
for the one who already in this room? Thank
Okay.
you.
Oh, many of.
Right.
We almost in. Everyone in.
I'm shy to open.
Okay. So welcome to the afternoon session. Shall we start? Yeah.
Yeah. I'm preparing. Okay.
Okay. So we have 3 speakers for the first session of the afternoon sessions. So may I call for the first speaker, Professor Wang Kun Chen from the Faculty of Industrial and Technology Management, Southeast Bangkok College, which he has said that it's new college, right? Yes.
Okay.
And his topic today is globalization, innovation, and sustainability research of aerosol science. So you have 20 minutes for your presentation. So please welcome, Professor.
Okay. How much time do I have?
20 minutes? Yeah.
20 minutes. Okay.
Yeah.
And did you see my screen? I've already shared.
Not yet.
Not yet. Hello?
Not yet. Maybe you can start sharing again.
Okay, that's Is it okay? Are you?
No. Anyone is okay? It's coming. I think. Hope.
Can you see?
But still the gray.
I think I have already shared the screen, but
Can you stop sharing and share again, please? Okay.
Yeah.
Now, okay.
Yeah.
Okay, so good morning, everyone. My name is Wang Kun Chen. So I'm very happy to be here. So I'm now working in the Southeast Bangkok College. This is a quite a very new school. It was born in 1999, so no more than 20 years old. So it is in downtown Bangkok, so it's very convenient and very close to the Suvarnabhumi airport. So just take the BTS and you could direct to our campus. So I'm very happy to be here. My title is a globalization and innovation. sustainability study of aerosol science. So actually, I will not talking about too much about the detail about the aerosol science and any paper, but I would like to tell you what I'm now working on, mainly working on. So and what we could contribute for the foreign the brand here in the conference. So just to let you see some of the pictures of Southeast Bangkok College. This is in the main campus in campus in the uh, Bana Station, close to Bana Station. So you can see here, this is a very high building, the 12th floor, and we have many of the conference rooms. So if we could have on-site conference, and this is a very good place. It's very convenient, and so what I would like to say is,
Could you please enlarge your PowerPoint?
can I?
Yeah, share in big screen.
Now it's big screen.
We still can see your outline here. So I think you did not push the button.
Can you? Okay, I'm sorry. Now can you see the screen?
Yes, we can see the screen. Can you enlarge it?
Now already large or no? Oh, okay. Maybe I'm not sure because maybe some of the technical problem here.
Yes.
Or maybe I mean, in the host computer can help me to share the screen. Maybe the effect will be better. Or just like now. Sorry.
Did you press the slideshow button already?
Slideshow the light. Oh, okay, I know you.
Yeah.
Okay. I know. So you right now? Is it okay?
Thank you.
Great.
Okay. So actually, I would like to talk about something about my background. My background is, in the very beginning, is atmospheric diffusion. So I do a lot of work about the atmospheric modeling. Then I shifted my background into the management. So
Be on.
I'm sorry. So I got another degree in economics and management. So I do a lot now. I do a lot of between the science and management. So so that's why I'm here in the in uh, in the faculty of management because I also teach the management. But because of the environmental background, so I'm mainly teaching about the green supply chain and sustainability education. And because 3 years ago I moved from Taiwan to here to Thailand, and now teaching in SBC. So I do a lot of work about the international conference. So I'm acting like the international conference organizer. So I organize a lot of international conference in this place, and I will show you that in different, but all related to the environmental protection and aerosol science. So we could encourage our student. I mean the undergraduate student or graduate student to publish their paper or present their their work in the conference. So what now I'm doing is I'm doing the study the atmospheric diffusion because I'm a modeler. I like the model. So and also I do some of the edit some of the material, teaching material of sustainability education. And now I'm working on SBC. We have a very strong team in supply chain. So I just add some of the essence that is called green supply chain management. And the last two is I'm a professional conference organizer, and also I am some of the journal editor, some of the journals editor. So I'm thinking here, I would like to talk because we just give a platform for the research. I think I'm now in SPC. So this could be a good platform because it's very convenient for all of us, even in Southeastern Asia country, ASEAN. So now because I will introduce some of, because I already have some of the team in the management expert. So because from another, not only in the nature science, we are thinking about the management science. So we could solve the environmental problem by social science method. And also, I'm here already 3 years, but many of the friends, they are very familiar with the situation in Thailand. So here in the Southeast Bangkok, we will have the graduate school of master degree and doctor degree. Although they are not in the environmental science, but they are mostly in the management science. But they are also, a good, I think, brain resources or labor resources for the study. And finally, I'm also editing some of the journal and organizing the international conference that both in China, in Thailand, Philippines, Japan, Indonesia, and Malaysia, and Cambodia, many places. So I will introduce this. And here I also organize a association, NGO association. It's called Sustainability Management Association. So we are not only the expert in the school. We could include many of the experts from the industry. Okay? So what I would like to say is to have a brief introduction about mine. These are all these conferences are all also I all participate. This is the first one is a TNT. This is a IAC. There's a serious and technique and international aerosol conference. This conference is together with the Taiwan Aerosol Research, Taiwan Association of Research. So it held in everywhere in Asia area. So the first conference is held in Bangkok. And the second of TNT is held in Japan, Kitakyushu. And the third is held in Manila, in Philippines. And the fourth is in Hanoi, in Vietnam. And the fifth go to the Songkhla province of Thailand. And the sixth go to Cambodia. And okay. And then we go to the Malacca in Malaysia. So go over. And next one, we expect to be Surabaya, but due to the COVID-19, we cannot hold. So next year in the March 12th, we'll have the online meeting of TNT IAC, okay? This will be very cheap because just I want to encourage. So we have many of the enterprise donate. So they will donate the budget. So just encourage your student, the student to come, and they just want to submit the abstract, and the fee is very cheap. It's only $10. But if you participate in the conference, then we'll return back the $10, and you got the many of the award that is very valuable. Okay. The second is International Conference on Sustainability Management. That is in the last 2 years, I worked with girl universities. And I also participated in environmental chemistry in 2020. That is with the Malacca, MICAS, the association in Malaysia is online, okay? And we also have the IC International Conference of Globalization and innovation. That is Asian Innovation School, okay? The dean will come here, and the coming two is a crisis and opportunity management conference that will be held in SBC in the next January. So why is a crisis? Because maybe just like COVID, like global warming, it becomes a crisis. How to manage this crisis? So the conference, the theme is this. And also this is in Assumption University in the next year, July, in the International Conference of Organization Innovation. So these are the conference. So I also want to introduce the association that is a registered company, a registered firm in Thailand. So we could do many of the research through this association. This is Sustainability Management. It's a non-profit association. So registered in Bangkok. So we do many things. Okay. Yeah. This is we call I see the outcome of the smart code. So we help to do the conference design, article publishing, and research guide and journal editing. So our outcome will be article, books, project, and pattern. So we have now it's growing more and more. So our product, including the books or the journal. Okay, I will let you know. But I would like to show you some of the previous papers we have already published. The first one we call it, it's published in the IOP Conference Series of Earth and Environmental Science. And it is a indexing journal proceeding by EI and Scopus. So this is a paper and written by my student. Is a study of carbon reduction to prevent climate change, but using the financial method, that is by futures and options trading in Asian countries, in ASEAN. And then this is my student, my group, they are all undergraduate students, so they are very happy. So this is the conference of TNT IAC, that is in Malacca, in 2 years ago, before the COVID-19. So it is okay. And then we have this is the same, this just publishing in IOP-ES. And this is the abstract. I cannot go to the detail, but I think then we also have some of the people doing the aerosol science education. So this is a paper talking about how to use animation to promote the education of aerosol science. So this is also published in IOP, okay, informal education, okay. And then we also have this is another just doing some of the education, sustainability education, and published in IOP. So we have another paper that is management strategy. So we just use the management way to solve the aerosol pollution, air pollution. So we just now mainly talking about the carbon trading, but what is the best area for the carbon trading? So we define an Indo-Pacific common market. So this is Indo-Pacific for the trading of carbon in this area. And do we find any chance or any advantage for this region? And then it also comes to the International Conference of Globalization and Innovation. It is not mainly concentrated in the aerosol science, but we do have many papers. They are thinking and have many of the innovative methods for the prevention of air pollution or to control the aerosol pollution. And this is another, the coming will be held in January 27, next month. So we are welcome for all the students or to come here to join and submit your papers in this. And some of the paper we are joined to public in the journal I can introduce to you. So so this is I just briefly showing some of the journal I'm editing. I'm the editing in chief. So the first one is we publish in by IOP Publishing, and this is the IOPES Environmental Science and Earth Science. So it is indexing by EI Compendex and Scopus. The second is the International Conference of Globalization and Innovation. We just using this, and it will go to the proceeding of Scopus indexing. So I think it's very good for the student. If they have a very new idea, they want to present and give them an opportunity for the people, for the students of international exchange. And these are all now is online now. And this conference were held in different provinces of Thailand. This is a journal, a journal. We call this International Journal of Organization and Innovation. I'm also the editor of this, and I would like to encourage our students or our colleagues or friends here to submit your paper to the paper. This is indexing by EI. And now this is because I come here, and I come here, we want to have some of the with the sustainability research. So this is a very new journal. So it will have the first issue in next January, and it is a quarterly. So it will apply Scopus or SSCI maybe after 2 years. So it will be an international journal. It's a HCSR, supply chain and sustainability research. Yeah. And this is the aims and scopes of this journal. Okay. So finally, I would like to say because this is a conference and we meet together is not very easy. So maybe we'll have some, but I would like to doing some of this kind of research work. The first is environmental education in Thailand. I already have some of the teaching material, but I want to change it into maybe Thai, but it is now mostly in Chinese or English. And the second, I would like to, to work in some of the energy saving and carbon reduction, the green consumer behavior. And the third is the green consumption and about the carbon finance. That's my major. And also, if we have want to have organized some of the conference, I'm very happy to help because we have a enough group of people, and they could help to do some of including the previous the work and after publishing. So I think the time is very short, so I may stop here and very thank you for all of us to have the opportunity to be here. Thank you so much. Yeah.
Thank you very much, Professor Chen. So
Yeah.
we still have a few minutes left for question. Are there any questions from the floor? So he has introduced many journals and conferences for us. Yeah. I think environmental education is very important and still have to do many works on that, I think. Yeah. In Thailand, we also need this kind of studies.
So I think I'm sorry, how to cancel the sharing.
Stop sharing at the bottom of the screen.
Yeah, I'm finding.
Can the host control that?
I don't know. Now, can you directly cancel my sharing?
On the top of your screen, there's a red button.
Red button, I didn't see.
Move your mouse to the top of the screen.
Top of the screen. Okay, I didn't see. I'm sorry, I didn't see. Okay. I see. That okay.
Stop sharing.
Stop sharing. Okay.
Okay.
Is it okay now?
Yes. So we
Okay.
are now back together in one screen. Yes.
Okay.
Any questions still? So
You mentioned about the green supply chain, Dr. Chen. Can you say a bit more about that?
Maintain a green supply chain.
Yeah. Is
That
it
is,
a
I'm sorry, I
current
cannot
topic?
answer directly now, but we have many
Okay.
ways of, from the supply chain is from the beginning and to the end. From the beginning is the material, and the end part is or we are say that is the consumer part. But we are seeing sometimes we just use the consumer behavior. The consumer behavior, where that the manufacturer to do something, that the consumer, if they have the awareness of a green, so we are forced the manufacturer to do that thing.
I see.
But
Okay.
yeah. And the other
We
is
can talk more afterwards. That's okay. Thank you very much.
okay.
For the interest of time.
Okay, thank
All
you, Professor Chen. And now we move to the second speaker. So, Dr. Win, are you ready?
Yes.
Dr. Win Traivittyanurak from Chulalongkorn University will give a presentation on the computational atmospheric research in Chulalongkorn University. Okay, please welcome Dr. Win.
Thank you very much, Dr. Somporn. So the topic of my presentation is computational atmospheric research at Chulalongkorn University. So I'm from the Department of Environmental Engineering and also from the Professor Arun Sonte Center of Excellence in Environmental Engineering at the Faculty of Engineering, Chulalongkorn. So firstly, I would like to quickly introduce myself. So my background is in environmental engineering, and I graduated from Carnegie Mellon for my PhD doing modeling work on aerosol microphysics on a global model. And I did a postdoc in Scotland, continuing to use the global model and applying observations from multiple platforms. So then afterwards, I worked at the Department of Highways for 10 years during my scholarship condition. And starting from 2020, I started my career in academic at Chulalongkorn University. So my experience at the Department of Highways involved environmental impact assessment. So my work experience there and my research interest in modeling sort of reflected in the courses that I teach now at Chula, which is EIA and modeling of environmental systems. And my research interest is in ultrafine particles, PM2.5 forecasting, and sustainable development of green infrastructure. So now that I'm going to talk about modeling, why does one do modeling? So the obvious reason is that a model helps fill the gap where there's no monitoring data. We cannot have air pollution monitoring everywhere, but a model can suggest where is a good place to monitor. And in some unfortunate event, like accidental release or explosion, a model can support the decision how to minimize the impact to human and to the environment. And a model can simulate scenarios with different sources included or track pollutants from individual sources. So that helps us better understand the origin and fate of pollutants. And a model can forecast the distribution of pollutants, and this information is for the benefit of everyone's health. We can also use the model to forecast impact of certain activities, and that is useful in impact assessment purposes to support decision making on permitting a development project, for example. Okay, so with these goals in mind to help support air quality management for people's health and for decision making. What we do at Chula includes emission inventory, chemistry transport model, and dispersion model simulation. So in case you're not familiar with emission inventory, it is a comprehensive listing of emissions in a geographic area during a specific time. You can think of it as a map of emission data. And when we do modeling, it is very important to have an accurate emission inventory. Sometimes we have to create the emission inventory for the simulation of interest by ourselves. Sometimes we improve upon the existing data. The figures on the slide here gives an example of improvement to emission inventory in the case of mercury from coal-fired power plants in Thailand. The original inventory in the model Geochem is on the left, and it is created from country level emission data and partially distributed onto the map using population density as a proxy. But it's not too hard to understand that in reality, the emission from coal-fired power plants should be concentrated where the power plant is located, and that is more resembles to the picture on the right, and that is what my previous work has been involving. So when we want to do a simulation for Thailand, it's obvious that we want to use the more accurate emission input, such as the one on the right-hand side. As for the chemistry transport model, we use the model called Geochem, three-dimensional chemistry transport model driven by assimilated meteorology, which resembles the real-world condition. And as for lastly, the dispersion model that we use is AirMod, which is a US EPA preferred and recommended model for regulatory purposes. AirMod simulates hourly concentrations as shown in the animation here, and it allows the user to handle the statistical summary in a flexible manner, such as maximum values from the simulation period or at a desired percentile, for example, like on the plot on the right-hand side. Okay, now that I list the things that we do at Chula and you get a better idea of our tools, I want to talk about pushing the boundaries because I personally believe in making things better. So there are three topics that I want to discuss. Firstly, about EIA and specifically about cumulative impact assessment. So firstly, I want to discuss about cumulative impact assessment. Is the background is the thing about EIA in Thailand is it looks at the impact of the single project and simulating only the sources of the proposed project, while treating the pre-existing pollution situation as constant. And that does not reflect the reality of the pre-existing varying condition, nor the true carrying capacity of the area. As a result, in the present EIA situation, there can be impacts that were neglected. So I want to challenge the single project assessment approach with cumulative impact assessment. And in doing so, we highlight the previously neglected impacts. By simulating comprehensive sources of pollution, cross-contribution analysis helps promote transparency and accountability, which goes in line with the principle of sustainable development. I want to make an example of this point by showing a case study of a power plant in Saratburi province. This work was done in collaboration with Naresuan University and also Greenpeace. So Saratburi, as shown on the map here, it's a province that is home to cement factories and also dairy farms. And Saratburi is also a strategic gateway province to the northeastern region of Thailand. Thus, highway traffic is also prominent in Saraburi. So this case is about a 150 megawatt coal and refuse-derived fuel power plant that was proposed amidst concern by local farms. So to tackle this, we use AirMod pollutant dispersion model as the tool for our investigation. We represent comprehensive sources of nitrogen dioxide for the domain, including road traffic and existing factories and mining activities. And we also looked at the 150 megawatt proposed new plant, which is situated in one of the pre-existing cement plants. So we learned that cows suffer from nitrogen dioxide more than people. The cow's threshold of impact on 24 hours average basis is 10 micrograms per cubic meter. And I'm pointing my cursor here on the graph so you can see the color contrast. So this 10 micrograms per cubic meter is lower than the ambient standard for humans. So we convey the risk to cow's health by using this plot, and you can see that we simulate the different scenarios. So the left plot is from the scenario with the highway sources only, and the yellow area demonstrates the area of impact that would be caused by only the highway traffic. And on the right-hand side, it's the impact that is caused by highway and the existing factories in the domain. So you can see that the yellow area is much larger. And when we look at the worrisome 150 megawatt new project, you can see that it's not making that much of a difference to the already not so good condition. And since we want to analyze the impact in cumulative manner, in the model, we can see the time series, and we can look at how often that the exceedance occurred. And finally, we can analyze the impact into the money term, that is the damage caused to premature cow death onto the 599 farms of the data that we got on the database. And we learned that the proposed 150 megawatt plant would add a little more impact to the area that already faced with impact from the existing industrial activity. And this is essentially about the carrying capacity of the area. We can assess the damage to cows and crops, and this sadly went unaccounted and therefore involuntarily fell upon the local people. So what is the way forward in this issue? So I hope to promote cumulative impact assessment and at the same time fostering capacity among modelers. And very importantly, we must promote the development of open access emission information database, because otherwise a comprehensive simulation will not be practical for the EAA business. The second topic that I want to discuss is on high resolution forecasting of aerosols. I want to aim for area-specific air quality forecasting that is relevant to people's livelihoods. Like, for example, shall I go exercise at this specific park this afternoon? What will be the PM 2.5 level there? So I want to develop high resolution model like 1 kilometer by 1 kilometer regional chemistry transport model. Nowadays in Thailand, people can easily access the PM 2.5 forecast from the app like Air Visual, for example, is by a private firm that sells air monitoring sensor device. As for the government side, Thailand Pollution Control Department is still developing its model for air quality forecast. If we look at Taiwan government agency case, they provide a 3-day air quality forecast in zones as shown here. Another example of more advanced system is from the US called AirNow. The platform can give location-specific air quality and recommendations. The cool thing about this platform is it presents air quality, both monitoring and model concentration, as well as forecast. Like in this example, screenshot from August this year, there was a forest fire incident, as you see the purple color here. So the forecast gives the information based on the forecasted wind of the next day, and together with the source information, the forecast can give information about what would be the pollution distribution tomorrow. And this gives the powerful information for people at risk in the downwind towns, so they can make plans whether to evacuate or to do some precautionary measures. Another example from NASA in a system called NASA GEOS, CF, standing for Composition Forecast. It operates at a rather large coarse resolution covering the whole globe. It gives forecasts with speciated details like in this graph. So you can see if there is a high pollution event in the coming days, and you see which species is the culprit. So you can find some ways to combat the problem in specific and efficient manner. So why am I showing you all these? So these are just examples of the existing situation and the way forward to develop high resolution forecast of aerosol. The plan is to develop a model called the WAF GC for WAF and geochem. And it's a regional model that has been implemented by research group in China. So we want to develop this for regions in Thailand. So it would allow us to go to find resolutions as fine as like 3 kilometers or 1 kilometer. But to do so, high resolution emission inventory will be critical for the model performance. The last topic is on advancing our understanding, our knowledge of ultrafine particle or UFP. Currently, there is no monitoring of UFP, while we have been worrying about UFP for a while. And now the WHO 2021 Air Quality Guideline just highlighted its importance. This is a big step in establishing the importance of tiny particles and particle size distribution, and also particle number concentration. So to tackle this, we must do more in monitoring and in research. Aerosol microphysics that can handle the processes that governs the aerosol size distribution will play a crucial role in advancing our ability to model ultrafine particles. The tool for handling aerosol microphysical processes exists in a global model like geochem chemistry transport model. This is an example of aerosol number predictions from geochem model. The plot shows number concentration at the ground level on the left-hand side and the vertical profile on the right. It highlights the importance of understanding the sources and the dynamics of aerosols, like emission from human activity near the ground and secondary formation at high altitude. This is an example of size distribution predictions in vertical profiles. This would help us advance our monitoring activities and the future policy management as well, and hopefully the forecasts that are relevant for people's lives. But the global model resolution is still rather coarse. So what is the way forward? So we aim to develop the regional model, the WAF, geochem, and TOMAS, which is the microphysical module, in high resolution regional CTN for regions of Thailand to forecast the size distribution and the ultrafine particles. But to do so, high resolution particle number emission inventory will be critical for the model performance. So in summary, as I have mentioned emission inventory so often, let's collectively put effort in developing open access emission inventory, both for gases, species, for aerosol mass, and also for particle numbers. Cumulative impact assessment will promote sustainable development, and high resolution chemistry transport model development is on the way. And lastly, aerosol microphysics model will help advance our understanding of outer fine particles. So that's all for my presentation. Thank you for your attention.
Thank you very much, Dr. Win, for your very informative presentation. So are there any questions from the audience? No?
Yes, I would like to ask some questions.
Please.
Yeah, thank you. It's a very, very good presentation about the modeling work. Yeah, I'm very interested in that. But I'm thinking about the emission inventory. Is there any? I think maybe it will be the limitation if we do not have enough emission inventory the database here in Thailand. The second question is you use the air mode, that is you monitor the nitrogen dioxide, but why don't you use the nitrogen oxide? Is that consider the photochemical reaction in the model? Yeah. And the third question is, you're here, in Taiwan, there's a single, independent island. But here in Thailand, even we have do a lot of abatement project inside of Thailand. But most of the pollutant comes from Myanmar, comes from Cambodia, comes from Vietnam. How can we do that? I think this is I'm thinking about, because maybe long time ago I worked in the Holland, Netherlands. Finally, they find that they already reduce all the pollution amount, but all the emission pollutant comes from outside, from Belgium, from Germany. So I think Thailand face the same problem here. Yeah,
Yep.
that's my question.
So I gather that there are 3 points about emission inventory. Totally agree that would be a limiting factor. So in Thailand, it's not like that we don't have data per se. There are like even a high resolution complete emission inventory for Thailand, but that sort of stopped at 2014. So that's quite old. And there is development improvement upon that already, but it's sort of like not easily accessible. It's in the institute that is working on it. So it's not like readily shareable for everyone. So you can imagine the difficulty of tackling this work, because different research groups have to do even sometimes, I don't know, repetitive work because of the factor that we are not easily accessing other people's data, I guess. So that's why I try to make a point that we should have like a common database. And in Thailand, there are the concept, the PRTR, which is a pollutant and transfer registration something. So that is still not happening, but at least we can see that in the policy side, there are some attempts to make this into a regular routine work. So I hope in the future we can have better emission inventory data. Your second question is on NO2 simulation. So in air mode simulation, there is the calculation that deals with the NO2 conversion already. So that's sort of taken care of in the calculation. But just represented to easily understand as NO2. And your third point is about transboundary pollution. And I totally agree that it's a very important issue. And that's why I feel that modeling work can really help, can really play a big role in this, because it can settle the debate whether the pollution that we are facing here in Thailand, how much of it is from local sources and how much of it is from transboundary pollution. Because without modeling, people who do monitoring, they try to infer some information and like sort of like, okay, looking at satellite hotspot, and okay, this must be from somewhere there with the hotspot, but you can't really say how much contribution, how many percentage of a given day is contributed by transboundary pollution. So that's why I think modeling can really help there.
Yeah, thank you so much.
Thank you for your question.
Thank you very much. I think we don't have enough time for the next question. So if anyone still have question, you can type it in the chat box. Thank you, Dr. Win, for your presentation. Yeah. So shall we move to the last speaker of this session, Dr. Karuna Jainonthi. I think she is ready for the presentation. She is from Rajamangala University Technology, Lanna, and her presentation is the designing of mindset on air quality concerning. Dr. Karuna, please.
Thank you, Chairman. สวัสดีค่ะทุกๆคน Hello everyone. I prepared presentation in video form, so I will present that I prepare. Okay.
There is no sound yet, right?
I'm not sure where I have to set on the open sound. I will check.
Dr. Sharita, maybe you can help the suggestion and share with sound.
Share content.
I
ต
just
รงปุ่ม
know
ที่จะแชร์มันมีรูปลำโพงอยู่อะครับ
ยังไงนะคะ
พอเราจะกดแชร์คอนเทนต์แล้วมันมีปุ่มที่มันเขียนว่า automatically optimize อะไรประมาณนั้นแล้วข้างๆ
ต้องเปิด
ปุ่ม
เสียง
ที่
ใช่
เขี
ไหม
ยนว่า
คะ
แชร์ audio หรือไม่แชร์อะไรเนี่ยเป็นรูปลำโพงอยู่อะ
ค่ะ
มีไหมครับ
Sorry for inconvenience แป๊บนึงเห็น
ลอง
เป็น
stop
ออโตเม
แชร์
ติก
แล้ว
อะ
แชร์
ค่ะ
ใหม่ไหมครับ
โอเคค่ะแชร์ลิงโอเคไปเกณฑ์แชร์ยังไงโอเค Hello everyone, my name is Karuna Jainonthi. I am chemist of Faculty of Science and Agricultural from Rajamangala University of Technology, Lanna, Chiang Rai. My research experience comes from three parts. First, basic knowledge from doctoral degree level. I study about chemical analysis using chemometric technique. Second, working with community
Hello
part.
everyone,
My
my name
area
is
Pan, Chiang Rai, Thailand. Tilapia culturing is popular activity that gain a lot of profit to province. But this activity profit is destroyed from qfish situation, which make people lost their turnover. The cause of qfish are global warming effect and low quality water management. Another topic that I'm involved is air quality concerning. In winter every year, northern Thailand people suffering from PM 2.5 smog, which also come from the low quality of air pollution management too. I'm realized that the air quality topic is urgent to cope with as well as water quality issue. The third part that make my skill research increase is the presentation for knowledge exchange between researchers in the specific field. My present work obtained first data analysis of chemical information that working with Mae Fa Luang University. Second, water quality analysis of aquaculturing that working with RMUTL. And the third, air quality evaluation working with Mr. Colin Chen. The research impact which gain to social are increased value of unique species of coffee bean, promote water quality management in aquaculture, and change mindset of people based on the understanding of reaction effect to air pollution. In the topic of water quality evaluation, I work as chemical staff to check the effectiveness of the proposed system using FB compared with the control system in the topic of preliminary study of the effect of airfly bubble or FB on the growth rate of Nile tilapia in Pan district, Chiang Rai, Thailand. The concept of using FB generator as aeration in aquaculturing was present in the third ISHP MNB symposium that set up in Japan on 9 to 12 May 2018. The development of culturing system using FB as aerator also adding the water treatment that improve water quality inside the pond. This concept was present in the fourth ISHP MNB symposium that set up at Ayutthaya, Thailand in 2019. In this year, the incorporation of different types of FB generator into the culturing system was studied to increase fish health and decrease solid wastewater. On the air quality topic, I was started to study with Mr. Chen to explain photochemical oxidation in air quality model. The paper was focused on the discussing of chemical reaction which using in the different kind of the model. This is the latest presentation that am distributed in the NYChem 2021. In another, my interested topic is the development of environmental course which designed to bachelor degree students. The focus of the presentation was related to the design content of environmental concerning into 15 to 16 weeks using green chemistry concept. I would like to be participate as the topic of big data environmental information in Thailand, PM 2.5 situation and management, and zero waste for better air quality. This is the short briefly of my research point of view. Thank you very much.
So is this
Okay, this is my story.
okay? Thank you, Dr. Karuna. So we still have plenty of time for questions. So, do you have any questions or comments on her presentation? So please.
I have a question for Dr. Karuna. Thank you for your presentation. So you mentioned about one of the work that you compared the photochemistry in models. Can you tell us a bit more? Yeah.
The paper that I work with Mr. Chen, right?
Yeah.
We prepare 3 model of air pollution model, and we use some chemical reaction to explain to make it clearly and compare that which one is better.
What models were the 3 models that you used?
Could Mr. Chen tell more about detail, please? The plum model is the first thing, and the another I cannot remember the name of it, but it used the different way to calculate to make prediction of air pollution.
Okay, it's okay. I can ask you more through email.
Okay, thank you.
Any comment from Professor Chen?
Yeah, I would like to ask a question. That is because Dr. Karuna, you have also mentioned that you are doing the measurement of the water quality, and you are also doing some of the air quality. So are you interested in developing a model from the water to the air? I mean, the interface. This could be maybe important in some area of that.
You mean how I switch to concern more about air pollution, right?
Yeah, because you have already conducted many of the experiments that's measuring the water quality, and now you move, and you also have many of the study dealing with the air quality. So maybe you could find some of the interesting topic to develop the interaction between water and air phase.
I found that I call it crisis too. When farmer farm Nile tilapia in their pond, the suddenly death or of fish in pond is quite make them lost their money. So I consider deeply not more than the water quality, the air quality or the weather is very very important too. So climate change or the pollution that make cloud to cover the fish pond will be make the management of pond better to reduce the ratio of fish die. That in my mind too. If I know more about the weather or air pollution that will make situation in my area better.
Thank you. Thank you.
Okay, thank you. Any more questions? So we still have maybe 10 minutes. Yeah, about 10 minutes more, or we can stop here and then come back again for the next session. Shall we keep the time the same? Start at 2:25 in Taiwan or 1:25 in Thailand?
So we will have a 20 minutes break.
Yeah, according to the schedule, we
How
have
about we take 10 minutes break? Huh?
over
Yeah,
to you, Danny.
It's okay. I mean, if you want to a bit earlier or just follow the schedule.
follow the schedule. Okay.
Yeah, I think follow schedule could be easier. So we'll come back to at about 2:25 in Taiwan and 1:25 in Thailand.
Yeah.
Okay. Yeah.
Thank you.
Thank you.
Thank you, Professor Sapom. Thank you.
Welcome. Danny, I cannot join the next session. I might leave soon, so
Okay, no problem. Thank you. Thanks for your help today.
talk to you again. Yeah.
Yeah, I think I will contact you by email these days for like AAC conference.
All right.
So
All right.
yeah, we will talk in email. And thank you. Thanks for your help today.
Thank you for the invitation and see you again. Bye bye.
Bye bye.
Bye bye. And say here. Yeah. Okay. Sorry. Okay. So, shall we start now, Professor Ding?
Yes, anyone?
We have 14 participants. I think most of the participants are already in the meeting room.
Yeah, sure.
But the most important is our speaker. Okay, so Dr. Chenny Chen, are you in the meeting room? Dr. Chenny Chen is the first speaker, and the second will be Dr. Shibin Lee. Okay, Dr. Chenny Chen already in. So we just so I think and Dr. Wong Wong was already in. Yeah. So now I think most of our participants are already in the meeting room, and we just welcome our first speaker is Professor Chenny Chen. He is coming from the Assumption Universities, and he has a very strong group of in the management group, and talking about some of his experience and contribution to quality management.
PowerPoint. So do you see my PowerPoint?
Can see.
Okay,
Yeah.
thank you. All right, it's my great honor for this opportunity to participate in this forum. Especially, I'm originally from Taiwan, but I've been in Thailand for more than 30 years. I have Thai nationality. So anyway, I really would like to help to connect the higher education between Taiwan and Thailand. And so I really willing to join in this forum. Okay, so but today I didn't prepare anything in terms of this kind of scientific or engineer technology aspect because my team is mostly from management field. So maybe I just share some of my research team member and then to identify or to explore some possibility topic related to our environment or sustainability topic in the future. So sorry, I hope I don't waste you guys' time. I don't waste your time. So let me try to introduce so myself, Chen Chen, is my Thai name. So mostly we come from the Assumption University of Thailand, and we call Asia Innovative School. And under the Graduate School of Business and Advanced Technology Management, Assumption University of Thailand. But before that, I have been working or teaching in Chulalongkorn University Business School, called Chula Business School, for more than 20 years. But I retired, so I moved to Assumption University. So I will try to team up my member from AIS, try to can contribute or participate in some kind of research field, maybe more or less from social science, in management aspect, if I can, on my team. So I have many years of working experience teaching in Thailand. So when this morning we discussed, and also I learned from Ajahn Win from Zula or Zula. Because in Zula we have very strong environment management program, and they also have PhD in environment management program in English. That's an English program. I used to introduce my Taiwanese friends son to study in that program. So that's a quite nice program. So this morning I try to learn from his presentation, and also I find out that wow, I'm not taking knowledge at all in my presentation. I feel sorry for that. So, but mean the professor or lecturer in Zula Business School, I also have some experience related to real sector. In sector, I used to be a management director of 2 listed companies in industrial sector. Also, I used to operate one paper making factory, paper mill. If you guys can understand Thai, the บริษัทกระดาษสีสยามจำกัดมหาชน So I used to MD there. So surely, as you may know that paper making is also very highly polluted industry. So we do have to take care of our air pollution, air emission, and also water pollution. So from the last 20-something years, I'm working in this factory. We really find out the environment standard getting higher and higher from the Thai government. So that is something that we're gonna maintain. So in addition to that experience, I also in our social study or management study, we also try to put in this kind of sustainability, environment protection, this kind of idea into the topic or issues. Take example, we are put in the corporate social responsibility is one of very important issue. That's many of this kind of research, they start to conduct how to be a good behavior, good citizen behavior of the society or the country. So corporate social responsibility or ethics, being a good manager, leader of the organization, one part of ethics should also looking for the advantage, the benefit of public. So environment protection is one of very important issues. And also, we also have some kind of study. Take example, this morning, Dr. Win also mentioned that green hotel, all right, green purchasing behavior or eco hotel, especially after this COVID-19, we all understand that in the future, when you back to the normal or after normal, maybe we are going to focus more in this kind of concept, green hotel, especially tourist industrial, which about 20% of the total GDP of Thailand. So Thailand maybe we can convert, change us into this kind of green tourists to make sure that all our tourists, our purchasing behavior, everywhere, every site we go, we visit in Thailand, seaside, mountain side, they are all well protected, environment well protected. We are trying to minimize our damage to the environment. So even we are social science researcher, we are also try have some kind of contribution, can participate in this great idea of the environment. So in my team, we have a teaching and research team. They're very diversified abilities, understanding, experience. So we are trying to accumulate our experience, our capability, our knowledge, try to work hard to carry out more challenging research projects in the future, especially related to environment. So I would like to try to introduce some of my team members. So this is Assumption University of Thailand. Also, I'm working in now AIS Asia Innovative School. All right, so Assumption University, please allow me a very short introduction of this university. This is the largest, most internationalized university of Thailand. This is a Catholic university. So Assumption University before we call ABAC, Assumption Business Administration College. So from the name, you understand that it's original from business administration, from business. So gradually to grow into a large university, comprehensive university. But surely our strength is still in the business administration. So we try to diversify into some engineer, all right, more or less in IT, digital design, this kind of engineering, science field. But major field, we are still concentrated, focused in business administration. But anyway, we have two campus. We are the old campus in Burma and the new campus. This is a new campus. That's a very grand design of very big campus. Also, when you design this campus, you also bring in the environment friendly, environment protection, or the idea or concept into design the campus of this campus. Okay, so this is Assumption University. So in my team under AIS, I have several members. They have different background. I will go through very fast. I hope I don't waste too much time. All right, so I myself, I'm from the strategy because my master and doctor are all from United States. My doctor, I follow the founding father of strategic management, Dr. Igor Ansoff. I went there to follow him to study strategic management. So I may try to contribute in my training of the strategic knowledge of strategic analysis in this kind of maybe AL, environment quality management. We also have Dr. Fugger. Dr. Fugger, he is also working in the United Nations. He is good in, he's from the education field. So his major topic research maybe related to sustainability research in the air quality management. Also, Dr. David, his background is from industrial engineer, also from the United States, maybe more or less in this kind of systematic approach or analysis. And we try to focus in the air quality management. And Dr. Lin, she also from the, we call the so-called education field. So it's an education for circular economy. So in education field, we also try to come out to be related to the environment, taking as the circular economy. So Dr. Luz, her background is from psychology. She's a consultant in the psychologist. So she may can contribute that how can we apply the psychological influence of pollution or try to motivate the people's attention toward the environment, toward the air quality consideration or concern. Dr. Fender is an application. He is very good in the AI. His focus research is AI and IoT. So we can ask him to apply his AI IoT in air quality management. The last but not the least, Dr. Patrick. So he's also in terms of environmental quality or the building, the build. Okay, Patrick. So we have this kind of allocation of different function in our team. So the next one, talking about myself again. Now I'm the dean of the Asia Innovative School. So I'm the associate professor, Assumption University of Thailand, and also I'm still with the adjunct professor of Chulalongkorn University, Chulalongkorn Business School. I'm still teaching Chulalongkorn in the BA, in the MBA International Program, MM International Program, and Master of Arts, Cultural Management, also International Program. Most of the program I'm teaching is in English in Chulalongkorn University. I also had some experience to participate in some kind of conference or even a journal. Take example, I used to be I was an organizer of the International Conference of Sustainability Management. So this is quite related to our topic today. Also organizer international conference, globalization and innovation. Also the International Conference Organization of Innovation. So this is the conference combined with the so-called journal. I'm also the editor in the journal Organization Innovation. In addition to that, I'm also the editor of some of the, we call the Thai TCI, Thai Citation Index, or Thai journals. Take example, the Journal of Global Business Review under the Eastern University or Budapest University in Thai, or in Chinese you say 东方大学, and it's a public university, Budapest University. Okay, I'm also the editor member. I'm also the editor member of the Longput Journal. This is a TCI Tier 1 journal. So all this relationship or all this connection, I also can contribute in our study. Also, Dr. Huger, as I say, he also a member of the United Nations. So engage in the teaching the community development of the United Nations Agenda 21. So he also in charge of the Chinese teaching of the UN or the UN, because you may know that United Nations have a branch, have an office in Bangkok, Thailand. So the next member is David, as I mentioned. His background is in industrial operation. So his operation research is systematic analysis. So he has done many research on the control of traffic flow based on the system analysis theory. So this kind of traffic flow, I think, also strongly related to the air emission. So maybe he also can participate in some parts to expand his basic study and expand to related to our air quality management. So this research will help us to do research on the control of automobile pollution. And the good news is that Thai government also set up the new development policy. They want to promote the EV, electric vehicle, So that should be a good thing to save, to help to protect the air quality. So one of the largest enterprise or industrial group of Thailand is also belong to the public sector, the government control of Photo. They also invested one new subsidiary, want to promote EV. So they set up this kind of corporation. They bring in the technology from Taiwan. So we all know Taiwan, they come up with this kind of platform to help all the company. If you want to come out your own EV, then you can base our platform and easily to design to come out your car according to your schedule. Next year, the first model will come out. So this is the good news. And also, in addition to that, like from China, the Great Wall Motor, GWM, they also introduce bring in your EV and start going to launch in the market. I think very soon recently. All right, and also from China, there also another automotive company also try to introduce your EV to Thailand. So I believe that in 2 or 3 years, in Thailand, the EV market, we are going to very hot, very heat. And also the Photo, this project, I really pay much attention on that because one of my students, my Chulalongkorn master student, now he's working under this project. Their progress is going very smooth under the assistance from Taiwan. So here we believe that Dr. David, his research also can help us on this control automobile pollution. Next one, Dr. Lin, so she has implemented many practical teaching research. So she actually did a lot of teaching practice research on circular economy. So it's also one of the very important parts of our work, so-called the environment. Okay. So next one is Luz. So Dr. Luz is an educational scholar and a psychologist. So she's interested in various psychological phenomena caused by civilized society and the mental illness caused by environmental problems. It's also one of her research passport. So we, in our different background or the knowledge experience of my team member, so she can contribute from the human side, from the psychology side. Many problems caused many come from this guy, external environment. So I believe that she also can contribute, give us some kind of new idea, new idea. When you're talking about so serious of environment technology or even environment science approach, now we can contribute some different point of view. Okay, so the next one, Dr. Fender. So Fender Spatial, as I mentioned, is an artificial intelligence, also Internet of Things. So these two things, we also can do research on using this AI and IoT to control environmental quality. Next one, Patrick. Patrick is from civil engineering. So from civil engineering, so very easy to diversify into this kind of environment consideration. So he has also done research on environmental control or built environment quality. So even in the civil, in the construction industry, even in Thailand, now we notice that the real estate still keep growing, especially in Bangkok. So we can expect that the real estate business in Thailand will still growing for at least 10 more years. It's still always in heat. Especially as you guys may know that the news say that the first speed train from China, from Kunming, already connect up to Laos, to the capital of Laos. Then Thailand, we are going to be up from Bangkok, go to Kola, Hongkong, and finally we want to connect with the Laos, the first speed train. After the connection, we will go down. Now we are going north. We are going down to Malaysia, to Singapore. So to come out the Sino, and then the whole fast speed train connection will come out to form up this traffic line. So under this kind of trend, gradually, Thailand is going to be the center of in terms of location, going to the traffic or transportation hub center of this Sino-China Peninsula. So under this, I believe that Thailand has also a long way to go for our real estate business or real estate industry. So Dr. Patrick, he can contribute a lot. When you build up the environment, how to bring in this kind of environment-friendly technology or solar, bring in the solar cell or any kind of things we can try to apply and put in the design in our building. So that's the good aspect, good point of what we also can contribute. So next topic, talking about myself, what kind of major event help myself. This I mentioned already, International Conference Sustainability Management, year 2020, 2021. We hope we can continue it up for long time. International Conference of Globalization and Innovation, also International Conference Organization Innovation. So with this, in fact, in Assumption University, we also have one very hot topic called organizational development. Organizational development, I'm going to join in another organization we call the Global Association of Organizational Development, OD. This is very strong, the strong research team in Assumption University. Maybe we also can invite them to join. Okay, so next one, Internet Conference is a detail in the January 15 to 17. So this conference, we focus, the main topic is sustainability management. So we focus on the sustainability science and environment, measuring and monitoring of sustainability, application of sustainability, policies and laws related to sustainability, sustainable production and consumption, effects of global climate change on development and sustainability. Even I'm not really the expert in these fields, but I really enjoy to share, to learn from all my colleagues and also all the participants. They present, they sharing their research on these topics. And this one, International Conference of Sustainability Management, here, that we also invite a keynote speaker, the associate professor, Dr. Anisa Osman from Malaysia. She's from Malaysia University, very outstanding researcher in this field. International Conference Global Innovation, the Globalization Innovation. So in this, our topic, majorly the symposium provide international forum to discuss topics and developing new knowledge related to the industrial globalization and the technology innovation. We aim to develop revolutionize the science and technology in line with the innovation management goals. So innovation, when you're talking about innovation, you cannot get rid of, you must mention the sustainability. We don't want to innovate, then go on. No? Okay, innovation, how to make your innovation sustainable. So just one idea, we're talking about IPO. So usually I is innovation. So many people, get your innovative idea, they can start up some kind of good idea, innovative idea or the business. We hope this kind of innovative idea, we can help you to register your intellectual property in order to protect your individual advantage or benefit toward your contribution of this kind of innovative idea. So P, in addition to P, we hope we can go up also public offer. Then we hope that your business, your company can start up a new startup and grow to the stage that you are large enough to be listed in stock market. So at that time, we can see that you are much better in the sustainability development of your company. So this kind of innovation idea, finally, you're going to move into a sustainability for sure. So now all the innovative ideas, all the new startup, you must consider how to make, first one, your business sustainability. In order to make your business sustainability, you're going to consider your business model, your product must be environment friendly, can be sustainable, can be human, human environment protection, can be benefit to the human being. So that's a very common value of the human now. So the symposium also serves as a platform for academicians, researchers, policymakers, and industrial professionals to present and promote the latest issues and research findings in the area of industrial collaboration and the technology innovation. So in addition, it's a give opportunity to participants to explore the new and the future technology in related areas. So based on this, we hope our social science researchers can try to apply lost technology into your own field, no matter it's in the field of psychology, in the field of education, in the field of business administration, no matter what's over your field. So the symposium also was aimed to foster an interdisciplinary discussion and networking to further enhance and enrich the knowledge of participants in industrial globalization and technology innovation. So lucky is that is our conference, even that is online conference. In 2021, it's still on site. Then the second time is online conference, but we can say that we can come out very fruitful and a very good result for our conference. So this is the ICGI 2021. We also the workshop on advanced education technology. After that, we also can try to train our participants, especially they may master or doctor students in any kind of institution, they can attend this kind of workshop to learn more what is the innovation, what is the sustainability, what is the new environment-friendly technology, and then how to use them to conduct your research. Okay, so this is the photo of the situation we have. It's AOI year 2022. Okay, so our strengths. So here I want to mention that we is a team from management experts from social science, have a different background. We are trying to help to contribute to help to solve the environment problem by social science method. Also, we're familiar with the current situation of Thailand, especially in Thai society. Okay, graduate student resources, because that I'm working in the graduate school, So we can use the students as our resource. We also can guide them to conduct their research related to the environment topic. So this is our best resources. Our team, professor and the research team, and also our students. So, all right, maybe with some experience of editor-in-chief, IOP, assistant editor, IJOIO, that's for your information. So research topic, maybe we try to consider, we discuss, try to offer some kind of research topic for your consideration. Maybe we can join in this part of the research. Take example, the first one, we say the research on environment management strategy in Bangkok, Thailand. Or maybe we can have some kind of topic like organizational development research on establishing effective air quality management, or analysis of green consumer behavior, or especially the purchasing behavior. We have one in our management, we have one deal we call planned purchasing behavior, or planned consumer behavior, okay, for energy saving and carbon reduction. Or research on the teaching mode of air quality management. Or we also can conduct this kind of air quality management in different campuses, in Thailand, or even in Taiwan, or even in mainland China, okay, or different institutions. Research on the analysis and the quantitative model of main factors affecting air quality management. And also research on the establishment of an NGO, non-government organization, for air quality management. So we can try to offer those research or studies to participate in our mega research on that. So this is my short introduction. I hope next time, our next forum, we can try to start to share with you some of our research results or findings with you. Thank you for your attention and your time. สวัสดีครับขอบคุณมากนะ谢谢各位的注意和关心的关注谢谢各位
Very good. Thank you for Professor Jenny Chen. It's a very exciting presentation, and we saw a very large group for air quality management. So they can use the social science method also. Yeah, very thank you for Professor Jenny Chen. Only to the limitation of the time, we can only allow the one question. Is there anyone want to talk something? The huge group. Is there anyone, or you have any? Looking at the capability of the team, you have any idea
if
about
no one
future
asks a question, maybe I can raise a question. Our host, National Taiwan University, yes, Professor 哪一个教授呢 ？Yes, yeah, you yes. So what kind of topic what I mentioned that you think is possible for my team to participate, and it is in your interest?
I don't know because I just came back last year and I heard some issue or like some techniques, for example, like AIoT used in the air quality control, but actually I don't really know how to combine them because everyone says their model is most efficient for the air pollution control, but I don't really know how it can be, practically used in this field. But if Professor Chen have some comments or some knowledge on this field, then can provide some suggestion.
Okay, never mind. So I think we can
have a
share
question.
The topic that my team try to brainstorm and come up some idea or some proposal, the topic. Maybe we can share with you by email.
Yeah, sure.
So email can give some kind of idea of research on environment management strategy or anything else on this topic. We try to to propose. Thank you for your answer. I think it's the right time for me to say.
You have a question to ask Jenny Chen?
Yeah, I have a question. So, in your talk, you mentioned about one of the guy who looked at the traffic data in some way. So, I'm thinking about the way to utilize traffic information in order to
very
make
good.
in order to make emission inventory from traffic sources. And since traffic data is can be modeled, and I presume that by using some intelligent technique, we can sort of create emission inventory that is as dynamic, as varying as the real world traffic behavior. So is it some kind of activity that your team is tackling, or is it on the things to do?
Yes. Thank you, Dr. Win. Well, I know you have from Chulalongkorn University. But we are very close to each other. I'm from the Chula Business School, just next to Chantrui Square. We are within the walking distance, right? You are under the engineer, right? Engineer faculty. Yes. My daughter also graduated from engineer faculty at Chula. Yes, thank you. Yes, I think it's a very good idea. Now, in fact, we already move into the so-called AI, even the big data. Big data, we can use the AI jobs and big data to help you. Maybe you are more in science, engineer, technology parts. Women can more in this kind of human behavior part, right? And then we can connect together to really can give the benefit to this universe, to this world. Thank you for your good idea. We can discuss that in more detail further. Okay? ขอบคุณมากอาจารย์วิน ถ้าอยู่จุฬาเดี๋ยวขอไปพบเลยนะครับ Sorry, even in Chulalongkorn University, we still conduct a teaching online. But in Thailand, the middle school or high school, the primary school, they are already go to the class. But Chula, the higher education sector, we still online. And our students, especially our BBS students, in fact, they don't like it. They don't like. They want to go to a school. They want to interact with the classmates. They want to participate in some kind of school activities. Like in Chula, our BBS, our CAS team are very strong. We win a lot of awards from the global CAS competition. Also, the business plan team also very strong. Sorry for that. Okay, so I hope we have some chance can catch up with you in Chula campus. Thank you.
Thank you for Professor Jenny Chen. I think it's a very good opportunity to link you together from engineering part and the management part. So I hope in the near future we will have more collaboration project between our science group and our management group in today's meeting. So that's just a thank you for Professor Jenny Chen. And then we will go into the next session that the talk will be held by Professor Shibing Lee. He is from the Ke Universities and he is now the Director of Public Health. So he will have a very good and interesting topic about the libido diminishing or raising under the installation of management fields. Okay, welcome, Professor Shibin Lee.
Okay, thanks for the introduction from the host, and thanks for the invitation to the 2021 Taiwan-Thailand Air Quality Conference. I'm Shibin Lee. I'm currently the chairman of the Public Health Department in International College of Ke University in Thailand. And today, the research I'm going to share was entitled as the libido diminution or raising under the inhalation of manganese fumes. So, if your opinions will stay in around like before 1991, maybe you would think the odor pollution of airs was maybe not directly harmful to the health of people. But currently, we change this opinion and we find unpleasant odors can be warning sign of potential risk of human health. Sometimes people can smell certain chemicals in the air before they are at harmful levels. Community members have reported that smelling odors in the air decrease their quality of life and sense of well-being. In present, noxious environmental odors may trigger symptoms by a variety of physiologic mechanisms, including exacerbation of underlying medical conditions, adverse conditioning phenomenon, stress-induced illness, and possible pheromone reaction. But however, unfortunately, we currently know very less about the olfactory-induced physiological response, not even than we consider in the pathological processing. Because for example, we know very less about the connection between the odor and olfactory receptors. We couldn't know which odors it was connected with what kind of olfactory receptor, and what kind of olfactory receptor activation will induce the illness or disease progressing. And we also know very less about how such kind of olfactory stimulations induce the physiological response, and such kind of physiological response, how to that connect with the pathology processing is through the neural innovations or endocrine or immunological response, but we still don't know that. So since the odor of the air pollutions will be some current issue about air pollution, so where are they from? They may from the garbage, trash, from agricultural waste, traffic, industry. They can separate some like terpenes, hydrocarbons, oxygenated compounds, ammonia, or hydrogen sulfide, volatile organic compounds, alkanes, aromatics, ketones. But I believe most of people you may thinking about like welding films, and I believe that most of us breathe when we pass by the welder welding. So do you smell something different? If you feel something different, well, maybe that is the point we want to talk about and share about in these sections. So what is in the films from welding? We always know the welding films were very tiny, and most of the time they are invisible by our naked eye. And the welding films will stick on our nasal cavities or the trachea or in our lung. So it may contain several heavy metals, including aluminum, cadmium, chromium, iron, lead, manganese. And the toxicity of the welding films, we can find they have aluminum, copper, iron, manganese, lead, nickel, zinc. And we found manganese is in the second high level of the heavy metal toxicities. It will harmful to our neural system and our lung systems. So why we should consider the odor of manganese film? Because several things. Long-term manganese inhalations will decrease the kidney weight, and olfactory manganese exposure would enhance the anxiety-related behavior. And fortunately, in 2018, we found that inhalation of manganese fumes induced the olfactory response, and such kind of olfactory stimulation will going to impair the renal functions. So if we think manganese will induce the olfactory response, but who responding to the sensing manganese in olfactory endothelium? Through a previous study, we can find several candidates, and one we think it will be directly connect with that will be calcium sensing receptor. calcium sensing receptor, short as CASR, is triggered by divalent or trivalent cation and several polyamines, including spermine, putrescine, mercaptan, and we find that it could be triggered by the manganese ions. So calcium sensing receptor, although it is not in the same family of olfactory receptor, but from the GPCR topological research, CASR is really close to pheromonasal receptor. Maybe you are not very familiar with the pheromonasal receptor. It's a kind of pheromone receptor. So it still has the chance expressed on the olfactory epithelium, and especially it could be directly expressed on olfactory sensory neuron. So let's check about this part. We can find through the Western blot, we can find olfactory epithelium have the significant expression of a calcium sensing receptor, and its expression site always on the topical side of olfactory epithelium. And in this part, we find, well, it will be some lucky with that because calcium sensing receptor could be functional receptor to detecting the outside chemicals. And we also want to make sure it is the calcium sensing receptor is expressed on the cilia or the flagella of the olfactory sensory neuron, and we can find it truly co-localized with the C7ORF63 and ATCY3. And these two protein was specifically expressed on the cilia and the flagella on the olfactory sensory neurons. So we find the expression site is correct, and how about it's functional or not? So we drew the in vivo experiment, and through the intranasal loading of calcium sensitive dye, and we do the intranasal administration with saline and the manganese chloride solutions. We can find it could induce the calcium influx on the terminal side of olfactory sensory neuron. It directly on the surface of the olfactory bulb. And you can see this part is the manganese administrations. We can find it has a very significantly calcium influx. So it means if we exposure the manganese chloride in our intranasal cavities, and we will activate olfactory sensory neurons and forming the olfactory response on the olfactory bulb. So based on that, we move on and we want to understanding under such kind of olfactory stimulations, what's going on. And we can find after we do the intranasal administration with the manganese chloride, it will directly increase the blood pressures and decrease the heart rate and increasing the renal sympathetic nerve activities. And in the other side, we focus on the perfusions of the kidneys. We can find intranasal administrations with the manganese chloride. It will going to decrease the renal blood flow and also decrease the kidney surface microcirculations. And such kind of thing we only can know under the manganese chloride intranasal exposure. We were doing such kind of thing, but is that exactly initiated by the calcium sensing receptor? So we pre-treat with the calcium sensing receptor antagonist to inhibit the activation of calcium sensing receptor, and we can find if we pre-treat with the antagonist, and then we treatment with the manganese chloride, and we couldn't find the raising of blood pressure or decreasing of heart rate or even on the renal sympathetic nerve activities and the decrease of the renal surface microcirculations. And further, we want to know such kind of thing were directly related with renal function or not. We use the MRI and ionic contrast to estimate the renal filtration. And normally, the contrast will filtrate from the renal surface to the medulla in 5 minutes. But if we let the rat under the intranasal administration with manganese chloride, we can find most of the time the ionic contrast couldn't filtrate from the cortex to the medulla. So it means under the olfactory stimulations from manganese film, impairing our renal filtration conditions. So based on such kind of result, we can find such kind of intranasal administration with manganese chloride will going to enhance the global sympathetic nerve activities and including renal sympathetic nerve activities. In such kind of sympathetic nerve activity enhancement, we are going to lead to the glomerular filtrations decrease. And in the other side, and it will getting closer to our topic, how the manganese connect with the libido. Since previously we find if we let the rat under the manganese chloride exposure, it will going to increasing the heart blood pressure, and also from the previous study we find manganese exposure will going to downregulate serotonin, dopamine, and other neurotransmitters. And these neurotransmitters is really essential to cognitive processing and the control of social interactions, feeling of depression, suicide thought, and maybe lead to the appear of aggressive behavior or social problems, no matter on the workers or the students. And we can find in the criminals in the presence, and we can find with the high level of manganese chloride, they have the more serious problem on the violent crimes issues. And on the contrary, we think maybe manganese exposure will going to activate the aggressive behavior on human. But on the contrary, manganese was connected with the libido diminishment. From previous study, we found that chronic manganese exposure would cause a sexual impotence or libido diminution and lower the reproductive ability on the manganese exposed workers. So it is easy to understand that chronic manganese exposure would cause the neurotoxicity, and such kind of thing will going to damage the neuron innervated penile erectile functions. But however, how do we explain the connection between manganese exposure and aggressive behavior, especially connect with the sexual desire or even sexual violence, sexual assault? Does libido connect with the activation of olfactory calcium sensor receptor? So before we have to take a look about how the neural innervation of penile erections. Actually, in there, they have two neuron systems. One is from the pelvic nerve, and the other one is from the pudendal nerve. Pelvic nerve after the pelvic pelvis will forming cavus nerve. And cavus nerve is containing the sympathetic nerve activity and parasympathetic nerve activity. And it has been studied very clearly in cavus nerve. Sympathetic nerve is innervate the penile impotence, and the parasympathetic nerve is related with the penile erections. But we still have no very less about the pudendal nerve and its downstream dorsal nerve of penis. We don't know how to it related with the penile erections. And from previous study, we find if it can induce like sexual assault or sexual crime, it should be connected with the sympathetic nerve activities enhancement. So we think maybe we need to do more about the pudendal nerve and we want to understanding if the olfactory exposure about the manganese film will activate or inactivate pudendal-sympathetic nerve or not. So we're testing that. We found after intranasal administrations with olfactory calcium-sensing receptor agonist, we can find such kind of intranasal administration will enhance the pudendal-sympathetic nerve activities, and also it will directly increase the blood pressure and decrease the heart rate. And how can we know such kind of neural signal is from the sympathetic nerve or parasympathetic sympathetic nerve or the somatic motor neurons? Because we can tell from the details. Sympathetic signal was really unique because it will synchronize with the heartbeats. So after we intranasal administration with the calcium-sensing receptors agonist, we can find the enhancement neural activity will have the very significantly synchronized situations with the heartbeat. So we can tell such kind of enhancement is from the sympathetic nerve activities. And also, if we pre-treat with the calcium-sensing, the antagonist of the calcium-sensing receptor, it will likely to inhibit the enhancement from the agonist. And the other part, and most people will be curious about how about the parallel erectile functions. And we do the two experiment on rat. One is with the shunt operations. The other is from the bilateral pudendal neurotomized. It means we cut two side pudendal nerve and we to see what's going on its parallel erections. So we find in the high voltage stimulations, they can cause the similar parallel erectile functions and also have in the lower stimulations, and you have similar response. But different part is about that. If we do the intranasal administrations with the calcium-sensing receptors agonist, under the low voltage stimulations, the parallel erectile functions will go into enhancement to the and similar to the high voltage stimulations. So it means the activation of olfactory calcium-sensing receptor will going to enhance the parallel erectile functions. But on the other side, if we cut bilateral pudendal nerve, and what's going on? The enhancement was gone. We couldn't find the exactly parallel erectile enhancement on the same rate, although they have similar blood pressure enhancement. So based on such kind of result, we can get several things. First, under the long-term manganese exposure, the neuron toxicity of overdose manganese will damage the central and the peripheral neuron, and such kind of damage will going to lead to the libido diminishment and the paranoid impotence. But under the acute exposure with manganese film will stimulate the olfaction, and such kind of stimulation will going to increase the blood pressure and increase sympathetic nerve, global sympathetic nerve activities. And this enhancement of pudendal sympathetic nerve activity will induce the parallel erectile enhancement. So under the autonomic nerve system theory of crime, the increasing of sympathetic activity levels and the blood pressure will going to decrease the activity of cerebral cortex activities and also activate more aggressive behavior and also make people become impulsive. So who we are and what do we do in our lab? Our lab is a physiological and pathological experiment-based laboratory. We do animal cellular experiment and mathematical models to explore the disease progressing on the public health issue we are interested in. Currently, there are 3 PhD students and 9 master students under 2 supervisor advising. That means me and Dr. Wu. The currently issued 2 are including diabetes sepsis, chronic kidney disease, kidney stone, and olfactory stimulation induced physiological and pathological responses. So thanks for your listening, and any question and suggestion are very helpful. And we wish all people have a good data every day in the coming years and got the paper publishment every month and every year got the good financial fundings. Thank you. So any questions?
Okay, thank you for Dr. Shipley. Okay, according to the limitation of the time, we can only give one question. Is there any question? It's a very interesting study. Okay, Dr. Wing. Dr. Wing, you.
Hi, thank you very much. Very interesting, and I have to admit, really out of my expertise, so it's a lot of new things to learn. But one question that I have in mind is about the odor, the metric that we use to measure odor. So I asked this because I did one modeling project where we try to model odor level, and we model it by taking literature numbers of threshold concentration of different chemical species, and we sort of take the different concentrations of the different chemical species and divide by the threshold odor level, right? And then we sort of combine the different odor levels of different species into one metric. So I'm asking you because you seem to have very insightful, in-depth details about how our olfactory sensor is working. So do you think that by combining the odor levels of different compounds into one metric, is it a ridiculous method, or is it making sense in some way?
Pardon me, I couldn't get the question very clearly. So you mean how I do the exposure olfactory stimulations, or
No,
what?
no, no. I'm asking, do you think that odor metric can be combined between different chemical species that cause smell?
Yeah. So that is the interesting part, because calcium sensor receptor is expressed on most of olfactory sensory neurons. So in this part, we only focusing on the calcium sensor receptor is because it is most of the olfactory sensory neuron express calcium sensor receptor. It is independently with the other olfactory sensory receptors. So that's a reason we take the calcium sensor receptor and study that. And we can find several kind of, because until now we couldn't find the method to explain how can we smell the welding film. And most of the time, we consider we couldn't smell any metals or metal-related ions. So that is a really interesting part. But based on such kind of research, we find maybe not everything is directly connected with olfactory response. In here, I have to mention before, it's about from the topological research. Calcium sensor receptor is not close to the olfactory receptor. It's close to the pheromone receptor. So here we consider it's not like the olfactory stimulations, although until now, nobody knows it's olfactory or the pheromone stimulations. But based on the topological research, we prefer to say the activation of calcium sensor receptor should be connected with the pheromonal response, but not olfactory response. But however, currently all the editors, I mean the journal editors, they prefer to say no, they are not pheromone. They should be the olfactory response. So it is somehow it is a little bit hard for me to say I think it should be the pheromones, not the olfactory, but they say no, they are olfactory, not the pheromones. So I expect most of the time, especially like the physiological response should be directly connect with the like a pheromonal response, like previous I mentioned before here.
Okay,
So I prefer like
Professor
to say
Lee, it's
much more close
interesting,
to the possible pheromone
but
reaction.
I had to stop here because our time is
sorry.
limited. So over is
Okay.
about over so many times. So I have to. So I'm very sorry. But I have to. So, but you could continue your talk, and we could email each other for more details. And very thank you. It's give a very interesting talk. So we spend a lot of time. So very thank you for Professor Subin Lee. Okay. And our next talk will be Professor Wang Ming Wang. Okay. Professor Wang, are you online?
Yeah.
Okay, so you have 15 minutes for the presentation and
okay.
Okay, thank you.
Okay, I think I share my screen.
Yeah.
Okay. I think I need to introduce myself because I not come from the pure science. Okay, I from the management side. So actually, I born in Malaysia. So because my living environment and learning environment, so I can speak Mandarin, English, and Japanese. Because my first degree I take in the Japan, then I went to Australia, US. Okay. At the moment, what I do is totally different with both of you. Actually, I do is a green consumer behavior. We call the green marketing. At the same time, we also compare the cow culture. Okay, different country is a behavior different. This kind of thing. What I'm doing now, because it's a big data issue. Big data, I think 5 years before, is all academic industry people, we're talking all the big data. So I starting to work big data from this paper, this project. So I want to share some idea what we're doing. Okay. At the moment, I still focus my green consumer behavior this side. This is very basic introduction. Okay. Actually, I read this paper, not say right, not complete yet. It's an idea what we're doing. Because we know this conference next year they had a special issue. We focus this special issue, so we're thinking the air pollution topic and COVID-19. COVID-19 because it's starting from 2019, so it's a we call the unexpected event. So at the moment, what we find in the research area, okay, COVID-19 is affect the consumer behavior. We totally change our behavior, like social distance. You know how to wash your hand. Okay, this thing. Air pollution. Because we focus this conference, so we think about air pollution and COVID-19. Actually, we do the literature review, special PM 2.5 or PM 10 related to the COVID-19 case. Okay. This is why we find the literature review. The second thing, at the moment, many published papers, the focus is we call the big country like Europe, US, or China, Asia, Japan, this kind of country. But we still cannot find some paper regarding COVID-19 air pollution in the Southeast Asia. So we put this concept together, then we focus is the Southeast Asia. This is the first time we do the second data, the big data concept. So we try to get some data from the website. This is so we get it, but we still had the problem with the data at the moment. Okay, so in Asia we had the 10 countries. Why? I mean, how you select this country? We use the counter analysis. We base the 10 country information, total population, okay, growing rate of the population, and GDP, growing rate of the GDP, inflation rate. Finally, we had the one we call the business trade, currency, accounting balance, profit, loss. Okay, we use this 6 intake for the Worldwide Bank. For those 10 countries, we analyze, we find we only can do 3 countries in the one group. One is Singapore, Thailand, and Indonesia. Okay, the reason why, because we need to think in COVID-19 data and the air pollution data. Okay, Philippines, Myanmar, and Malaysia, we lost the data in the Myanmar, the COVID-19 air pollution data. Especially in the Brunei, because this is one group together. There's one group together in here. This group, we lost 2 country data, so we cannot do this group. Then the other group, Cambodia, Laos, and Myanmar. Unfortunately, same problem. We cannot find the data. So we only had the one choice to do this paper. Okay, in these 3 countries, that means the Singapore, Thailand, Indonesia. This is the reason we use crowd analysis to find our we call the country. The next day we use the other methodology. We call the generally analytic method model. Short form they call GAMN. This method the promote for the British one circular in 2006. Okay. In the past, the research paper, we know we had the time series data, we had the continued data, we had the category data. If we do the regression model, logistic regression, that means we can use continue or category data. If we put the time series data, then we call the time series analysis. We cannot use the data as a category. But we find this model, this statistic, GAMN can use 3 dimensions. I mean, if we data had the time series, at the same time we have the category, at the same time we have the continued data, we can use this statistic model to do it. This is the reason we use this statistic model. At the moment when we get data, we from Singapore, Thailand, Indonesia, before COVID-19 is 19, so we're starting 1 year before, after 1 year. I mean, we hope we can get the 3 years data. At the moment, the issue is that air pollution data we get only for the city. That means Singapore is a city, it's okay. But Thailand, we only get from the Bangkok, the Jakarta, present the capital of the Indonesia. So because the Jakarta, Indonesia, we had lots of mid data, like temperature, humidity data, we cannot have it. By Thailand and Singapore, we had, so we cannot use. So we only to use the PM 2.5 and PM 10. The COVID-19 data, we get from the country. Okay, that means we had from Singapore, Thailand, Indonesia. It's a whole country data, accumulated data. It's a new cases and new die, strategy in test. This one is very interesting. This one is depend the in test it depends the shutdown for the government. That means the like Thailand government, Singapore government, they give the ranking 0 to 100. That means 100 is a totally lockdown. Okay. The other data we have is total vaccine. Okay. Total vaccine, that means how many vaccine they give to the population or the customer or whatever, president. They had the other one we call the 1 star or 2nd star, or the 3rd one is a total boost. Okay, this is the data we have. So our missed data issue and concern issue maybe within our this paper want to write the age dependent variable is a new cases. Okay, the other 3 PN 2.5, PN 10, statistic intent, and the total vaccine will become the IV. Then the time series is a 3 years, 36 months. This is what we're thinking what to do. At the moment, we do very interesting statistic, discussion statistic report. But very interesting is that we know that COVID-19, a lot of government locked down the country 2 months, 1 month, 2 weeks, you know. Then you read the air pollution data, PM 2.5 and PM 10. Actually, in Singapore, there is something different. The something different compared to 2018, 19, 20 is not so much different. Okay. In other way, we assume the lockdown is not affect our air pollution. I'm not sure it's true or not, but based on our data, we think it's that. Okay, this is Singapore. The next one is Bangkok. Bangkok, I living in Bangkok from April until now, 6 months. When I come here, you know, I think beginning of the May, they had the lockdown again. But you compare 2018, 19, 20, the PM10 and PM 2.5 and PM10 is not different. That means that like cycle, the weather cycle session, rainy season or non rainy season. Okay. So because we had the 3 people in our team, so we think it's really the lockdown affect the pollution or not. But for this data, it's not. Okay, because you see the cycle is not different. How about Indonesia? Very unlucky, Indonesia, we had a lot of missed data. So Indonesia starting 2020, we can see the different thing, the PM10 and PM2.5. They do the upside down changing. Okay. I don't think so this is because of the lockdown issue. Because Indonesia very serious is this year February the starting. That means you can see the PM 2.5 still increase. In other way, the manufacturing is still working, although the government is locked down in Jakarta. Okay, that means this is what I mentioned, is it is a season issue or whatever. We don't know. Okay, the last part we use we don't put it together at the moment because we still have missed data. So this is Singapore new cases. And that means you see the floor almost the same. Okay, total facing when they're going out, the die is going down, new cases going down. What's at the moment we report to us? That means you get more vaccine, new cases be going down. When your new cases going down, that means the die number also going down. Okay. This one you see is the Singapore splitting index. We can see the lockdown percentage only in the starting here is around 2019 After that, Singapore government want to open the society country. That means the not say 100% lockdown, but the cases is not really, I say not really effect in here. Okay, that means you lock down, the mean cases still have. Okay, the other cases we can read is Thailand, Bangkok. This is not Bangkok, this is whole Thailand, sorry. This is new cases. This data is for 2019, not include the 2018, because 2018 we don't have the COVID. So you can see the recently the Thailand, the new cases is going down, the death rate, there's the mid data in here. So you can see that the up, down is very high. We need to double check the data. That means the new cases going down, the death going down, the vaccine going out, okay. Finally, the shutdown policy still maintained, like Singapore. We can assume that the lockdown policy is really work or not for COVID-19 new cases or die. Okay, this is other topic we need to discuss in future. Indonesia, this one is an Indonesia country. It's the same thing. Vaccine going out, new cases going down, die going down. Okay, the shutdown strategy in test almost the same. That means we can compare these three countries. If we consider the big data concept, we don't need the statistic analysis. We can ensure that the lockdown really affect it or not. We have the three country data, so we can ensure what the result come out. Okay. Based for our this topic or idea, is it this research topic can work in our conference or not? That's the one thing we want to ask. Okay. Second, we had the data problem, especially this morning I saw few presenters that can get the very good data from Thailand. But we try, need the help. Okay. Air pollution data, at the moment we had from the city, we consider is it possible we get from the country to do the, we call the divide by, to use the mean concept to average data to use. COVID-19 data, is it possible from the city? This is the other topic. If we cannot get the air pollution data from the country, in other way, we need to change our mind to get the city COVID-19 data. In the literature review, at the moment, almost the paper talking is the country extent data. So based on this topic, so we still try, it's possible. We want to focus is the country data because of the crowd analysis. We use this country. Okay, the data period. Because the GLMA model, at least we need the 26-month data. Is it possible we can collect 4 years until December of 21 this year? So we have the 48-month data. This is why we consider at the moment, we try to solve the problem. It's possible. We hope this paper can present in the next year conference. This is our, it's the idea paper, it's a concept paper. Any question to ask? Thank you.
Okay, thank you, Professor Wong. So it's interesting because though due to the time limited, so we can allow one question, anyone. Is a very interesting for the big data analysis of air pollution. I think in the future, it will be a very good topic for the deeper research. Is there anyone? So, so did you find, I asked one question, did you find any relationship between the COVID-19 and the aerosol concentration, I mean PM 2.5?
No, we not analyze yet because now at the moment we have the data issue because we need to find the country data, both sides. Air pollution is a country, or COVID-19 is a country, or we need to select the city. Especially Indonesia, Jakarta, we very difficult to get it. Thailand, Bangkok is easy to get. We call the city data, like COVID-19 new cases, new die, vaccine, this kind of data. But Indonesia, very tough.
Okay, okay. So thank you for Professor Wong. And now we are happy so that our three article already published. So I would like to close the session and I move the time to our chair, the Professor Ding. Professor Ding, yeah, welcome. Yeah.
Thank you. Thanks for Professor Chen's holding the last section. Yeah, I think for today's conference, we have a lot of excellent presentation, and I think we have some, ideas exchanged in different fields, and including air pollution control, modeling, management, measurement, something like that. So I'm not sure if anyone has more question for any speaker or this conference or any comments.
Yeah, I think Professor Ding, I would like to say something that we are very appreciated for the scholars from Thailand and the scholars from Taiwan. So it gives a very good opportunity for us to know each other. And today, because of the so we know how to, to have a new idea for the future collaboration of our research, especially in the multiple disciplines. So today we find many variable viewpoints. So I'm very appreciative. Thank you for Professor Ding and all the professors from Taiwan University and for all the professors in Thailand. Thank you.
Yeah, thanks for all professor efforts on this conference. Especially, I would like to thanks to Professor Chen. I think he helped a lot from the perspective of Thailand. Some invitation from him. So I think for this conference, really end now. If there's no any other problem, so I think, is it possible we can have a photos now, and everyone can turn on their camera?
One, two. Yeah. Wait. 1, 2, 3. Okay.
Okay. So
Okay.
thank you, and I would promote again for next year AAC and also TNT. And hope to see you next year
Okay,
or
see
soon.
you.
Thank you.
Thank you so much. Thank you so
Thank you.
much. See you.
Thank you.
See you.
If